The most boring stream on YouTube. Starting now. I gotta figure out the video card. Or the Vulkan API. I think it's the standard at some point soon. Super JavaScript Engine. Yeah. First, I gotta look up the Vulkan API standard. Figure this shit out. It's a collection of predefined functions. A big table of data, different structures with different properties. It's ridiculous. It's so dumb. I gotta stop winging it and figure this shit out. I gotta waste the brain power reading this dumbass documentation. Gotta waste. Oh, it's such a waste. I can't keep throwing it together though. It's a waste to learn. A PDF is the only way. A web, whatever you call it. That's not real documentation. If it's not in PDF form, it's not documentation. I can't move this window. And it's fucking annoying. So I'll get to the standard later. For right now, this standard. These are both terrible standards for really crappy products. JavaScript is shit. This Vulkan API. At least it's performant. But the API is trash. At least it has speed. Well, it doesn't suck that bad. JavaScript though, that's terrible. It's just the API for this thing is horrible. I don't like the fact that the whole GPU is hidden behind an API. The architect, what's it called? The ISA, instruction set architecture. That's the only way to program. Releasing like an API to program the GPU. That's like trash. It's so annoying. That's the only thing I don't like about it. At least make like, it's basically like a BIOS, except nobody uses the BIOS the way it was originally intended. Everything's shit. Nothing really matters. So I'm gonna like read through this, try to figure out how this all goes together. Get this shit running, because chatbot is useless. Chatbot is garbage. It's way worse than anything. It is not intelligent. Artificial intelligence is nothing. It's a fucking lookup table. It's like Siri, except I think Siri is probably better than it. Command line. So yesterday I made a type called the qua. Or a template called qua to stand for quad, but it doesn't necessarily mean 4 sides. So I moved the D so I don't mistake it as meaning literal 4 sides. And I guess qua does mean something, but that's like not relevant to anything. It's just called a qua, the template, whatever. And I got I gotta wake up. Everything that makes up whatever's needed to make this spinning quad takes several different properties attached to descriptor in the video card, checks the descriptor, and then it runs what it says, like recipe book, and it's cooking it, and it just makes whatever you put in. And then between all that, it has to be translated to machine code to run the instructions, because you can't just directly write to the video card because it's all hidden. It's monopolized. And the video card's a piece of shit. It's not that advanced. It does like the same trick multiple times over several things. The CPU is impressive. The general purpose CPU, the i7, the Ryzen, the fact that it can do addition, subtraction, division, multiplication, bit shift, operations, it can address memory. The things the CPU can do, the general purpose CPU can do, are impressive. The GPU is not impressive. The GPU is like a second-hand piece of shit. And it's overpriced as fuck. It does jack shit. It's not impressive at all. And they gotta wrap the whole thing up in a fucking API. They take all the money in your wallet to get graphics on the screen for a piece of shit You can't even access the whole fucking GPU without permission, unless you like hack the BIOS on it. Even then, it's not worth it because it's like garbage in the first place. So I don't know. I'm biased toward the GPU because of that. I hate the GPU. It's stupid as fuck. But I gotta learn the fucking API, I guess. Stuff is shit. Actual shit. Let's see what I can get done today. I got this new struct, whatever. The chatbot was wrong, which is why I'm gonna read the documentation, figure it out. I can't keep falling for chatbot. I think chatbot is able to do something because it's chatbot. It does have access to documentation. Except it's just fucking wrong 90% of the time. So I gotta look it up myself. But chatbot said that these are like the fields properties that make up the quad or a quad, or an example of what's needed to like make a quad, which is this. So chatbot says all you need are these things to hold the properties that describe and form this. And chatbot's wrong. Chatbot is so wrong. So I need to like figure out what's actually needed, because this is like wrong. It's partially right, but it's missing stuff. So I need to like check the documentation. Go through this fucking documentation. Figure out what's needed. Make a whole new list. Because I'm gonna need two or three of these, whatever. These quads to hold different parts to make this stupid shader program. So I don't know what I'm gonna do. That's about it. Oh, this sucks. I hate everything. I need some more ice water. I don't know. Get back started. Documentation. Woohoo. Not really. Like the opposite of woohoo. It's like boohoo. I don't even know where to start. So it's like, just start picking through documentation, figure it out. So that's where I start. Where's the fucking scroll bar? I hate the PDF viewer. Like some PDFs get a scroll bar, some don't. They gotta figure out what setting to turn on. Oh, it's so annoying. Oh wait, the scroll bar's back. Never mind. I guess it zoomed out too much. Why does it jump to the bottom of the page? It should reset at the top. Oh, everything's stupid.
Function declaration, a sync-generated declaration, and variable declaration bindings in global code.
That's this documentation, that series reading.
By this in global scope.
So enjoy the documentation.
Object value declarative
Because who doesn't love documentation?
environment.
Everybody. Nobody loves documentation.
Global code for the associated realm code except for function declaration.
Oh, I gotta figure this stuff out. I gotta focus.
Function declaration, a sync-generated declaration, and variable declaration bindings, var names, a list of strings. The string names bound by function declaration, generated declaration, a sync function declaration, a sync-generated declaration, and variable declaration declarations in global code for the associated realm. ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method, purpose, get this binding, return the value of this environment records this binding, has a declaration, n, determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generated declaration, a sync function declaration, or a sync generated declaration, has lexical declaration, n, determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property, n, determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare global var, n, determines if a corresponding create global var binding call would succeed if called for the same argument, n, can declare global function, n, determines if a corresponding create global function binding call would succeed if called for the same argument, n, create global var binding, n, d, used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If d is true, the binding may be deleted.
Hello, I'm Siri.
Hello, I'm Siri. 2. 1. 4. Technical terminology. The Vulkan specification makes use of common engineering and graphics terms such as pipeline, shader, and host to identify and describe Vulkan API constructs and their attributes, states, and behaviors. The glossary defines the basic meanings of these terms in the context of the specification. The specification text provides fuller definitions. Chapter 3. Fundamentals. This chapter introduces fundamental concepts including the Vulkan architecture and execution model, API syntax. 3.1. Host and device environment. The Vulkan specification assumes and requires the following properties of the host environment with respect to Vulkan implementations. The host must have runtime support for 8, 16, 32 and 64-bit signed and unsigned 2's complement integers, all addressable at the granularity of their size in bytes. The host must have runtime support for 32 and 64-bit floating point. The representation and endianness of these types on the host must match the representation and endianness of the same types on every physical device supported. Since a variety of data types and structures in Vulkan may be accessible by both host and physical device operations, the implement 3.2. Execution model. This section outlines the execution model of a Vulkan system. Vulkan exposes one or more devices, each of which exposes one or more queues which may process work asynchronously to one another. The set of queues supported by a device is partitioned into families. Each family supports one or more types of functionality and may contain multiple queues with similar characteristics. Queues within a single family are considered compatible with one another, and work produced for a family of queues can be executed on any queue within that family. This specification defines the following types of functionality that queues may support: graphics, compute, video decode, video encode, protected memory management, sparse memory management, and transfer. A single device may report multiple similar queue families rather than, or as well as, reporting multiple members of one or more of those families. This indicates that while members of those families have similar capabilities, they are not directly compatible with one another. Device memory is explicitly managed by the application. Each device may advertise one or more heaps, representing different areas of memory. Memory heaps are either device local or host local, but are always visible to the device. Further detail about memory heaps is exposed via memory types available on that heap. Examples of memory areas that may be available on an implementation include: device local is memory that is physically connected to the device. Device local. Host visible is device local memory that is visible to the host. Host local. Host visible is memory that is local to the host and visible to the device and host. On other architectures, there may only be a single heap that can be used for any purpose. 3, 2, 1. Queue operation. Vulkan queues provide an interface to the execution engines of a device. Commands for these execution engines are recorded into command buffers ahead of execution time, and then submitted to a queue for execution. Once submitted to a queue, execution. Once sub says ahead of execution time, and then submitted to a queue for execution. Once submitted to a queue, command boo. The execution engines of a device. Commands for these execution engines are recorded into command buffers ahead of execution time, and then submitted to a queue for execution. Once submitted to a queue, command buffers. Execution without further application intervention, though the order of this execution is dependent on a number of implicit and explicit ordering constraints. Work is submitted to queues using queue submission commands that typically take the form VKQ. For example, VKQ submit, VKQ binds pass, and can take a list of semaphores upon which to wait before work begins and a list of semaphores to signal once work has completed. The work itself, as well as signaling and waiting on the semaphores, are all queue operations. Queue submission commands return control to the application once queue operations have been submitted. They do not wait for completion. There are no implicit ordering constraints between queue operations on different queues or between queues and the host, so these may operate in any order with respect to each other. Explicit ordering constraints between different queues or with the host can be expressed with semaphores and fences. Command buffer submissions to a single queue respect submission order and other implicit ordering guarantees, but otherwise may overlap or execute out of order. Other types of batches and queue submissions against a single queue, for example sparse memory binding, have no implicit ordering constraints with any other queue submission or batch. Additional explicit ordering constraints between queue submissions and individual batches can be expressed with semaphores and fences. Before a fence or semaphore is signaled, it is guaranteed that any previously submitted queue operations have completed execution, and that memory rights from those queue operations are available to future queue operations. Waiting on a signaled semaphore or fence guarantees that previous rights that are available are also visible to subsequent commands. Command buffer boundaries, both between primary command buffers of the same or different batches or submissions as well as between primary and secondary command buffers, do not introduce any additional ordering constraints. In other words, submitting the set of command buffers, which can include executing secondary command buffers, between any semaphore or fence operations execute the recorded commands as if they had all been recorded into a single primary command buffer, except that the current state is reset on each boundary. Explicit ordering constraints can be expressed with explicit synchronization primitives. There are a few implicit ordering guarantees between commands within a command buffer, but only covering a subset of execution. Additional explicit ordering constraints can be expressed with implementations have significant freedom to overlap execution of work submitted note to a queue, and this is common due to deep pipelining and parallelism in Vulkan devices. Commands recorded in command buffers can perform actions, set state that persists across commands, synchronize other commands, or indirectly launch other commands, with some commands fulfilling several of these roles. The command properties section for each such command lists which of these roles the command takes. Action. Action commands perform operations that can update values in memory. For example, draw commands, dispatch commands, state setting commands update the current state of a command buffer, affecting the operation of future action commands. Synchronization. Synchronization commands impose ordering constraints on action commands by introducing explicit execution and memory dependencies. Indirection. Indirection commands execute other commands which were in the absence of explicit synchronization or implicit ordering guarantees, action commands may overlap execution or execute out of order, potentially leading to data races. However, such reordering does not affect the current state observed by any action command. Each action command uses the state in effect at the point where the command occurs in the command buffer, regardless of when it is executed. 3.3. Object model. The devices, queues, and other entities in Vulkan are represented by Vulkan objects. At the API level, all objects are referred to by handles. There are two classes of handles, dispatchable and non-dispatchable. Dispatchable handle types are appointed to an opaque type. This pointer may be used by layers as part of intercepting API commands, and thus each API command takes a dispatchable type as its first parameter. Each object of a dispatchable type must have a unique handle value during its lifetime. Non-dispatchable handle types are a 64-bit integer type whose meaning is implementation dependent. If the private data feature is enabled for a VK device, each object of a non-dispatchable type created on that device must have a handle value that is unique among objects created on that device for the duration of the object's lifetime. Otherwise, non-dispatchable handles may encode object information directly in the handle rather than acting as a reference to underlying object, and thus may not have unique handle values. If handle values are not unique, then destroying one such handle must not cause identical handles of other types to become invalid. and must not cause identical handles of the same type to become invalid if that handle value has been created more times than it has been destroyed. All objects created or allocated from a VK device, that is with a VK device as the first parameter, are private to that device, and must not be used on other devices. Three, 1. Object lifetime. Objects are created or allocated by VK create and VK allocate commands, respectively. Once an object is created or allocated, its structure is considered to be immutable, though the content of certain object types is still free to change. When an object is passed to another command, it may be accessed by the implementation, which may include both read and write access unless explicitly stated otherwise. Objects are destroyed or freed by VK destroy and VK free commands, respectively. Objects that are allocated, rather than created, take resources from an existing pool object or memory heap, and when freed return resources to that pool or heap. While object creation and destruction are generally expected to be low-frequency occurrences during runtime, allocating and freeing objects can occur at high frequency. Pool objects help accommodate improved performance of the allocations and frees. Applications are responsible for managing the lifetimes of Vulkan objects and memory passed into the Vulkan API. The access semantics of Vulkan, registered sign, 1, 4, 326A specific. Difference between VK create and VK allocate is one on a heap other in memory or is relation to mainboard RAM or GPU RAM. Great question. The difference between VK create and VK allocate functions in Vulkan doesn't directly relate to heap versus stack memory or mainboard RAM versus GPU VRAM, but instead to how Vulkan handles different types of resources. Here's the break. VK create functions. These functions are used to create Vulkan objects, typically things that are more logical or abstract in nature. Examples include VK create instant, VK create instance, VK create device, VK create buffer, VK create image, VK create shader module. What are all the VK create things? I warrant to make a macro to concat the VK create to the start of, or actually I can just concat, but list them all anyways, all the VK create post-pended calls. Applications are responsible for managing the lifetimes of Vulkan objects and memory passed into the Vulkan API. The access semantics of different functions in the API follow a typical pattern. Application-owned memory and Vulkan objects may be accessed at any time during the execution of a command they are passed to. Vulkan objects that device addresses are retrieved from may be accessed by the implementation anytime that memory backing the device address is accessed. Device addresses and Vulkan objects passed in during the creation or allocation of another object may be accessed by the implementation anytime that the created allocated object is accessed unless explicitly stated otherwise. Device addresses and Vulkan objects passed to a recording command vkcmd may be accessed at any time during the execution of the command, when the command buffer is subsequently recorded into another command buffer. During any subsequent command that is recorded to either the command buffer or one it is recorded into. When destroying or freeing an object, implementations must not access any memory or other objects that may otherwise be accessed when the object is accessed. Applications can free or destroy objects in any order, except that parent objects must be freed only after all child objects are freed. An object is the parent of another child object if the parent was used as the first object parameter in the creation of the child. Once an object is freed or destroyed, it must not be accessed again, either directly or via access to another object. Applications must not free or destroy any object while it is being accessed. 3.3.2. External object handles. As defined above, the scope of object handles created or allocated from a VK device is limited to that logical device. Objects which are not in scope are said to be external. To bring an external object into scope, an external handle must be exported from the object in the source scope and imported into the destination scope. 3.4. Application binary interface. The mechanism by which Vulkan is made available to applications is platform or implementation defined. On many platforms, the C interface described in this specification is provided by a shared library. Since shared libraries can be changed independently of the applications that use them, they present particular compatibility challenges, and this specification places some requirements on them. Shared library implementations must use the default application binary interface, ABI, of the standard C compiler for the platform, or provide customized API headers that cause application code to use the implementation's non-default ABI. An ABI in this context means the size, alignment, and layout of C data types, the procedure calling convention, and the naming convention for shared library symbols corresponding to C functions. Customizing the calling convention for a platform is usually accomplished by defining 3.5. Command syntax and duration. The specification describes Vulkan commands as functions or procedures using C99 syntax. Language bindings for other languages such as C++ and JavaScript may allow for stricter parameter passing or object-oriented interfaces. Vulkan uses the standard C types for the base type of scalar parameters, for example types from stint_h, with exceptions described below, or elsewhere in the provided by VK version 1.0, type def in 32 tvk ball.
Okay, maybe the API isn't that bad. Because booleans are stupid. And there's no like portable boolean in C for true false. Except this API, they actually took the time to account for booleans. So maybe it's not that bad, but it still sucks. But not as sucky as I thought. It's pretty solid so far, documentation wise. I don't know. I still think it sucks though. Maybe I'll think it sucks less later. But maybe it doesn't suck that bad.
VK-Ball32 represents Boolean true and false values, since C does not have a sufficiently portable built-in Boolean type, provided by VK version 1.0, type def in 32 tvk-Ball32.
I like how they do bool 32. It's like Boolean 32-bit. So you don't accidentally use a Boolean and think it's a byte or a bit. It's like obvious that like 32-bit, it's Boolean. I don't know, I can appreciate that. The rest is standard though. Crap. I need some more water.
Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N, V, D. Create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 4, 1 has binding. N, the has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, return true. Let objrec be envrec. Return objrec has binding, n, 1, 4, 2 create mutable binding, n, D, the create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and E, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the num n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If D is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, throw a type error exception. Return DCLREC create mutable binding, n, D, 1, 4, 3 create a mutable binding, n, S, the create immutable binding concrete method of a global environment record envrec takes arguments n, a string, and S, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the num n that is uninitialized. A binding must not already exist in this environment record for n if S is true. The new binding is marked as a strict binding. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, throw a type error exception. Return DCLREC create a mutable binding, n, S, for initialize binding, n, V. The initialize binding concrete method of a global environment record envrec takes arguments n, a string, and V, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, then a return DCLREC initialize binding, n, v. Assert. If the binding exists, it must be in the object environment record. Let objrec be envrec. Return objrec initialize binding, n, v, 1, 4, 5 set mutable binding, n, v, s. The set mutable binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and s, a Boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by S. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, N is true, then A return. DCLREC set mutable binding, N V S. Let OBJREC be envrec. Return. OBJREC set mutable binding, N V S, 1, 1, 4, 6 get binding value, N S. The get binding value concrete method of a global environment record envrec takes arguments N, a string, and S, a boolean, and returns either a normal completion containing an ECMA script language a value or a throw completion. It returns the value of its bound identifier whose name is N if the binding is an uninitialized binding. Throw a reference error exception. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by S. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, N is true, then A return. DCLREC get binding value, N S. ECMA International 2024 145. 3. Let OBJREC be envrec. Return. OBJREC get binding value, N S, 1, 1, 4, 7 delete binding, N. The delete binding concrete method of a global environment record envrec takes argument N, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, N is true, then A return. DCLREC delete binding, N. Let OBJREC be envrec. Let global object be OBJREC. Let existing prop be has own property, global object, N. If existing prop is true, then A. Let status be OBJREC delete binding, N. B. If status is true and envrec contains N, then I remove N from envrec. C return status. Return true, 1, 1, 4. 8 has this binding. The has this binding concrete method of a global environment record envrec takes no arguments and returns true. It performs the following steps when called. Return true, 1.
This video's like so dramatic. Like I've never taken, like thought, an escalator could be so dangerous.
On October 23rd, 2018,
Like, wow.
football fans were
Like it's an elevator. Three million people. Oh my god. People are amused by the simplest shit. The general public plays video games all day, consume media. They waste their lives doing recreational drugs. Watch videos like why an escalator handrail moves faster than the stairs. What are you learning if you're not applying anything that you do? What's the fucking point? Why are you even alive. There's so many people. They need to like figure out their lives, get their shit together, stop absorbing. Now I'm gonna like waste my time playing this for a second.
On October 23rd, 2018, thousands of football fans were making their way to the game in Rome. Excitement for the game was high, and the fans began to chant and sing. At 7:03 p.m.
And then the animation, they make the people like red. And it's like, oh my god, it's so dramatic.
around 50 people were riding the long escalator down to the platform. But within 30 seconds, the
And then it all goes wrong. Bum bum bum.
crowd had swelled to nearly double that. Everything seemed fine, but inside the escalator
And the music's picking up. This is so funny.
was a problem.
Oh, this is hilarious. How could you make something? It's so like commonly overlooked, so dramatic. This is great. This is gold. Alright, it's totally worth the 3 million views it got. It deserves it.
The weight of the passengers was bearing down on the steps, and
So dramatic, it's awesome.
the load on the main motor was increasing. To try to slow the descent, the motor applied a counter torque. But as the force continued to increase, the stairs began to move faster.
And like one of the animation, like, oh no, something's up. No one else gets what's going on. This is like amazing. This is like cinematographic gold.
By 7:04 p.m., the crowd had tripled. The motor finally reached its limit, and under the massive strain, the drum
It's like a story arc. It goes up, has a climax, and it's a go down. But it's about elevator. This is great.
began to slip. With the motor losing control, the escalator triggered its second line of defense. A safety relay tripped, immediately cutting power to
The sound like affects the quality. Top tier.
the motor. The main brake clamped down on the metal drum to stop the descent of the stairs.
This is like so cool.
But it failed. The friction on the main drum wasn't enough to stop the motor from spinning, and the stairs
And then the people turn red. This is great. This is golden. It's all about elevator. It's like you can make the most boring topic interesting with like, yeah.
continued to accelerate. Sensing the motor had lost control of the steps, the escalator engaged the last line of defense. In the event of an emergency, an
And that one person in the crowd. They're like, I told you so. I told you something was up before it happened. Oh, it's this guy's video. Okay, he's cool. I forgot this is whatever.
control of the steps, the escalator engaged the last line of defense. In the event of an emergency, an auxiliary brake is designed to bypass the motor entirely and directly lock the drive shaft. Under normal circumstances, the chance that all three safety measures fail at the same time is vanishingly small. But these weren't normal circumstances. At 7:05 p.m., the third and final safety system failed, and the stairs began to plummet. Fans were flung forward and started streaming.
That's actually kind of funny. Now, if someone got hurt though, but I would assume that you'd be able to catch yourself. And people would stop stepping on at that point, but people, they probably kept walking on, and they're like a whole crowd of people. Yeah, that could get dangerous. Whoever's at like the end of the pile, they can get whacked by the stairs. Yeah, that could break someone's leg. So it's not funny, I guess.
Streaming down the escalator. Some leapt over the central barrier in desperation, while others were swept into a crushing pileup. At the bottom, the landing became a dangerous choke point.
Oh god. Someone dropped their, is that wine or beer? What a waste. But look at the fucking dam. I guess it's not that funny. Whoever designed that, the backup system, very poorly. Yeah, they didn't do a very good job on the safety systems. That's pretty bad. As long as you jump, you should be okay though.
Under the pressure, the steps twisted and buckled into jagged metal, leaving 24 people injured.
That would hurt.
Something like this shouldn't have been possible, and experts at the time knew that something had gone wrong, and they started to suspect foul play.
In the aftermath, Rome's transit agency sealed off the accident site and closed the Republica station for several months.
The authorities ordered both a technical and a criminal investigation, and the mayor even publicly vowed to discover the cause of the accident. So investigators began dismantling the wreck, tearing it down piece by piece to reconstruct what had happened. The ride people experienced
On October 23rd,
publicly vowed to discover
Was that blood? I think there was blood.
the incident. So investigators began dismantling the wreck, tearing it down piece by piece to reconstruct what had happened.
That's probably paint. Blood turns brown. I don't think that's blood.
The ride people experienced on that escalator was one of the most terrifying rides.
Why go on like a merry-go-round or like a roller coaster? You could go on like the escalator of death.
Of their lives. But
That's a ride. Alright, I gotta like read this documentation. Oh, this is so boring.
VK true represents a Boolean true, and signed integer 1, value, and VK false a Boolean false, and signed integer 0, value. All values returned from a Vulkan implementation in a VK Ball32 will be either VK true or VK false. Applications must not pass any other values than VK true or VK false into a Vulkan implementation where a VK Ball32 is expected. VK true is a constant representing a VK Ball32 true value. Define VK true 1U. VK false is a constant representing a VK Ball32 false value. Define VK false 0U. VK device size represents device memory size and offset values provided by VK version 10. Type def int 64T VK device size. VK device address represents device buffer address values. Bid VK device address size 11,364. A valid VK device address must be equal to the sum of an address retrieved from a VK buffer via VK get buffer device address, and any offset in the range. 0. Size, where size is the value of VK buffer create info. Size used to create that VK buffer. Bid VK device address none 10,894. If a VK device address was retrieved from a non-sparse buffer, that buffer must be bound completely and contiguously to a single VK device memory object.
I want to make a macro called vk create, then vk destroy. Because I'm lazy. And when I read vk create, if it's like connected to the rest of a word, like vk create image, vk create buffer, vk whatever. I'm too lazy to like separate it as vk create, and then it's a buffer. So see it as one thing. So I'm gonna make a macro that concats. So it'll be easier to see where create's called and what it's being called for. Oh, I'm so bored. And I'm like, go through documentation, make some macros, figure stuff out. That's about it. I gotta focus. I cannot focus. I really gotta focus. capital and lowercase letters are stupid. Typing up the word create and destroy. It's a whole lot of letters. This is too lowercase. I guess it's a font too. Lowercase. So I can type VK new, VK free. Less letters than typing up the whole word create and destroy. And then create and destroy. That's too confusing. New is clearly like new allocation. Free means free the memory. Create and destroy is like annoying to read. So we can go through first, replace all these. Do I need the parentheses? Oh, it's just whatever. Alright, so I'm gonna go through first, rename all this stuff. And I guess continue through the documentation. This way I can go through. It'll force me to like evaluate the code again. I can check everything as I go through. Now that I know that create and destroy, make new memory and free it, even though you can tell from the name itself. It's gonna force me to go through and reabsorb what I've read over and over again already. And I can check to see if there's anything funky going on. Because Chatbot makes crap code. And I did have to set up a loop at the, not a loop, just like a section at the bottom to free all the mallocs that Chatbot made. But I'm pretty sure Chatbot didn't correctly free everything. So I'm gonna go through and rename everything, and then I guess later I can check and free stuff if I missed it. All I gotta do is get like a base understanding of how this stuff is like linked together. But create and destroy, that's called a bunch of times. Create's called 39 times. Destroy is only called 13 times. So it's like 3 times difference. Are some things not being freed in memory that could potentially make leaks? Or is it because they're grouped up in arrays and then there's a loop that does 10 frees, but the calls to create are inlined? So there's more create calls than there are free calls. I don't know. So I'll look into that too. Oh, real-time programming sucks. I need a time machine so I can just get the result and not have to actually program. That'd be great. But no, I have to spend fucking time. Oh, the first one, yay. Create image. So now it's gonna be a new image. Well, that's annoying to read. Dang it. Maybe we'll just do this. There is a period somewhere in here that looks like a period, but it's not actually a period. It's like a square or something. Maybe I should use that as a separator. This is not, this is a different one. I'll just concat it. Let's do this. Make sure it builds. Oh yay, an issue already. Was it glue or did I call it macro paste? I called it glue X. Huh. Is image a reserved word? Are you kidding me? It better not be. Fucking fuck. This is why namespace collision is an issue. Exactly what I complained about, I think, yesterday. The fucking namespace, X image. Someone already took the name, image. It's the most annoying fucking shit. Fuck. I can't just do the simplest little things because the modern operating system is absolute shit. Windows will die, Mac OS will die, Android will die when a new operating system comes out. It's be way better than this shit. It's all gonna die. I need some pop.
One, 4. 9 has superbinding. The has superbinding concrete method of a global environment record env-rec takes no arguments and returns false. It performs the following steps when called return false, 1, 4, 1, 0 with base object. The with base object concrete method of a global environment record env-rec takes no arguments and returns undefined. It performs the following steps when called return undefined 9, 1, 4, 1 get this binding. The get this binding concrete method of a global environment record env-rec takes no arguments and returns a normal completion containing an object. It performs the following steps when called return env-rec 146 ECMA International 2024. Note: global environment records always provide a this binding. Note: global environment records do not provide a super binding. 9, 1, 4, 1, 2 Hasvar declaration. N. The Hasvar declaration concrete method of a global environment record env-rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called let var declared names be env-rec. If var declared names contains n, return true, return false, 1, 4, 1, 3 has lexical declaration. N. The has lexical declaration concrete method of a global environment record env-rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called let dcl-rec be env-rec. Return. dcl-rec has binding n, 1, 4, 1, 4 has restricted global property. N. The has restricted global property concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called: let objrec be envrec, let global object be objrec, let existing prop be global object, n if existing prop is undefined.
It's 2025. It's like secondhand programming. Fucking idiots. It's fucking stupid as fuck. It's literally intentional. Because if the operating system at a fundamental level has C language at the core, if every single program runs on the operating system but it's compiled separately, it's not really part of the operating system, then the operating system, it doesn't really take responsibility for your program, because your program's a separate C program or compiled in assembly. So it's really on the developer, not the operating system. So if the C language is separate from the operating system, and the operating system says, oh, we'll just run C language or assembly, but you gotta meet these rules. So you meet the rules, you make your fucking program. How you make that program doesn't matter, just as long as you make the program to run in the rules of the operating system. And even when you follow the rules, you get fucked, because the modern operating system isn't very modern. And the only reason that they provide the C program or the C language for free is to make sure it stays the way it is. Because it's not about making life easier. It's not about making programming more convenient. It's about making a status quo where everything is shit and keeping everybody in the same shit. Because only an insane person would release something better than the status quo. Because whatever you release is going to be stolen anyways, even if you protect it. Because you can't protect it on the modern OS. It's 2025, and namespace collision is still an issue. I should be able to say in my fucking program, this is my namespace starting at this point. And the compiler should say, whatever the fuck that was using that defined image as X image. And why the fuck is someone defining image as X image? Just use the word X image. For fuck's sake, why do you gotta change a word to something else? But this shouldn't affect me. I should be able to just write some fucking code, not have to worry about the headers from other files or programs. But I have to worry about it. Because it's 2025? Yeah, no. I gotta get this JavaScript engine out first. I can't take this though. It's ridiculous programming in 2025. It's literally the 1960s. And if a more modern operating system, a real operating system was released, the modern operating system would not be able to compete. It would just disappear. Because who the fuck wants to put up with this 24/7? Do you know how much money you would make as a company if you didn't have to deal with shit like this? The productivity would go way up. The bugs would go way down. The entry level, what you would have to know, would go down. It'd be more on skill, not on the bullshit that you know that has nothing to do with the actual program. Because 90% of programming is gatekeeping and making things more complicated than it needs to be. It's intentional. It's freaking elitist shit. Everything is so fucking dumb. Just so annoying. I can't waste my time looking up all these keywords that could possibly overlap with something else. Maybe I can redefine these with an extra underscore. Or put VK in front of it. But everything already has VK in front of it. Oh my god, everything is shit. Can do this. Fuck. I think I know what it is too. It's that fucking whatever header that's used to load the image from the file into to make a pixel buffer, whatever that fucking program. I'm pretty sure it's that header. Starts with X image. I think it's that header. Dang it. Maybe there's a way I can concat the tokens without having to fucking deal with this shit. Chatbot says, you're running into the preprocessor problem, where some other header. Oh my god, it's X11. That's even more annoying. X11 is from the 1980s. No duh. Literally, fuck the world. Everything is so fucking stupid. Oh, 1987? Okay, that's so modern. It's 2025. So chatbot's explaining the obvious. Define image as X image. So every plain image in your code gets replaced, and your VK image in your own image type explodes. In macros, you can concat tokens safely. Well, I do think, I don't know, this macro takes 2 steps, glue X. I think it's like to glue the value of the name, or it glues the name if it doesn't have a value. Do I have a macro called glue X and paste X? Let's make a macro called concat. Will this work? Wow, thank you, chatbot. Thank you so much. So chatbot's actually helpful. So glue X does paster macro. Which does the same thing. Oh, it's the spaces that make a difference. That's fucking stupid. This caused an error. There's no error. Okay, I just don't care. I just don't give a fuck. This means though that the name on the right hand side needs to be the exact name, which is fine in this case. But the other way, how it concats, is it gets the name that it holds if it has a name. So I lose that ability to doing it this way, whatever. But this works, so whatever. Except namespace is still an issue. Because now if I ever want to make something, which I wouldn't, that's why I have these super long names for things to avoid that scenario from happening, so I make really fucking long names. But if I ever did want to find something which like would be useful, except I know it wouldn't be a good idea. But if I ever want to make something called image, I can't, because X11 is using that word. So we like define image potato. I'll just do like 23, I don't know. I can't do that. Where's potato? Or just say 1, 2, 3. But I can just override image. How is that not an issue? Where's the headers at? What did I find before it? What do if defined? As I'm checking if image is already defined with if defined. Already like defined. What the actual fuck? Did I spell image right? You kidding me? Holy shit. Okay, so I'm gonna check if image is defined. Paste it here. Oh my god, what the hell? Then how is it an issue? Why the hell can't I do this then? What's going on? Okay, I'm gonna undo all this. I hit save. Build it again. What the actual fuck? Now it's not an issue? Are you fucking kidding? What happened to X image? Oh my god. Oh, it's because the macro, that's why. I gotta put this back to paste text. There we go. Okay, so why can't I glue it? How is it not defined, if it is defined? I don't understand. Is it like a magical define? What the fuck is this? Says that's a sharp observation, the reason is subtle. And it trips people up a lot. Wire, if defined, doesn't fire. Only in the context of object like macros. If somewhere in a header file like this, image is defined as a macro, but you must check with if defined. What? Huh? What the hell is chatbot talking about? That's not even valid. Is it? That's valid? What? And it's not an error? Oh my god, I'm so confused. What is going on? Programming is shit. C language is trash. I already tested this. For the love of cheese. Both will correctly catch X and image. It doesn't. It doesn't catch shit. Pasting what chatbot said. It doesn't catch anything. Why? I tried and it does not work. It does not catch it. Is it a type? Oh my god. No. That's why I don't like type define. Okay, I just don't care anymore. I just, whatever, fuck this shit. I got a solution and it works. Just gotta concat it slightly differently and it works though. So I'm gonna go through the rest of these, find replace, check the code around it. What does vk get? I like get those macros too. All the like get set, free, getter setters, view, destroy. I want to wrap them in macros. So they're easier to read. Because I'm lazy. I want to like read it and know right away. I'm gonna find replace, get done, whatever. Any more ice?
Return false. If existing prop is true, return false. Return true. The 1st of April 2015 can declare global var. N. The can declare global var concrete method of a global environment record env takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called: let objrec be envrec, let global object be objrec, let has property b, has own property, global object, n. If has property is true, return true. Return is extensible. Global object. Note properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147 9 1 1 4 1 6 can declare global function n. The can declare global function concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called: let objrec be envrec, let global object be objrec, let existing prop be global object n. If existing prop is undefined, return is extensible. Global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values, true. Enumerable, true. Return true. Return false, 1 1 4 1 7 create global var binding n. D. The create global var binding concrete method of a global environment record envrec takes arguments n, a string, and a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called: let objrec be envrec, let global object be objrec, let has property b, has own property, global object, n, let extensible be, is extensible, global object. If has property is false and extensible is true, then a perform. Objrec create mutable binding, n, d, b perform. Objrec initialize binding, n, undefined. If envrec does not contain n, then a append enter envrec 7. Return unused, 1, 1, 4, 1, 8 create global function binding, n, v, d. The create global function binding can create e method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8 replaced. It performs the following steps when called: let objrec be envrec, let global object be objrec, let existing prop be global object, n. If existing prop is undefined or existing prop is true, then a let desc be the property descriptor, v, true, true, d, else a let desc be the property descriptor, v, perform. Define property or throw, global object, n, desc, perform. Set global object, n, v, false. If envrec does not contain n, then a append enter envrec. Return unused, 48. ECMA International 2024. Note: global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls, 1, 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding, and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms, 1, 5, 1 get binding value, n, s. The get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called: assert s is true, assert envrec has a binding for n. If the binding for n is an indirect binding, then a let m and n to be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value, n2, true. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note S will always be true because a module is always strict mode code 9.1.1.5. To delete binding, N, the delete binding concrete method of a module environment record is never used within this specification. Method, purpose, create import binding, N, M, N2, create an immutable indirect binding in a module environment record. The string value N is the text of the bound name. M is a module record, and N2 is a binding that exists in M's module environment record. Get this binding, return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note module environment records are only used within strict code, and an early error rule prevents the delete operator, in strict code, from being applied to a reference record that would resolve to a module environment record binding. C13.5.1.1.1.5.3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called return true, 4 get this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called return undefined, 5 create import binding, N, M, N2. The create import binding concrete method of a module environment record envrec takes arguments N, a string, M, a module record, and N2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name N. A binding must not already exist in this environment record for N. N2 is the name of a binding that exists in M's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called assert. envrec does not already have a binding for N. Assert. When M is instantiated, it will have a direct binding for N2. Create an immutable indirect binding in envrec for N that references M and N2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9.1.2.1 get identifier reference, env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called if env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env, name, strict, empty. Else. 150. ECMA International 2024. Note: module environment records always provide this binding. AB. Let outer be env. Return. Get identifier reference. Outer. Name. Strict. 9.1.2. To new declarative environment. E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment, O, W, E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called let env be a new object environment record. Set env to O, set env to W, set env to E, return env, 1, 2, 4 new function environment, F. New target. The abstract operation new function environment takes arguments F, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical, else, set env to uninitialized, set env to new target, set env to f, return env, 1, 2, 5 new global environment, g, this value, the abstract operation new global environment takes arguments g, an object, and this value, an object, and returns a global environment record. It performs the following steps when called: let objrec be new object environment, g, false, null. Let dclrec be new declarative environment, null. Let env be a new global environment record. Set env to objrec, set env to this value, set env to dclrec, set env to a new empty list, set env to null, return env, 1, 2, 6 new module environment, e. The abstract operation new module environment takes argument e, an environment record, and returns a module environment record. It performs the following steps when called: let env be a new module environment record containing no bindings, set env to e, return env. ECMA International, 2024 151, 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields: field name, value type, meaning, outer private environment, A, private environment record or null, the private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names, the private names declared by this class. 9. 2. 1 Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy env. The abstract operation new private environment takes argument outer privy env, a private environment record or null, and returns a private environment record. It performs the following steps when called: let names be a new empty list. Return the private environment record. Outer privy env, names, 2, 1. To resolve private identifier. Privy env, identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called: let names be privy env. For each private name Pn of names, do A of Pn is identifier. Then, I return Pn. Let outer privy env be privy env. Assert. Outer privy env is not null. Return resolve private identifier. Outer privy env, identifier. Point 3 realms. Before it is evaluated, all ECMA script code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24, realm record fields, field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and v, an array, f, the agent that owns this realm, the global object for this realm, the G, global environment for this realm, meaning, the intrinsic values used by code associated with this realm, a list of records, with fields are, a string, and a module record. Note 1: once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2: as mentioned in host load imported module, 8 Note 1. In realm records is only used when running an import expression in a context where there is no active script or module field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called let realm rec be a new realm record. Perform create intrinsics. Realm rec, set realm rec to agent signifier, set realm rec to undefined, set realm rec to undefined, set realm rec to a new empty list, return realm rec, ECMA International 2024 153, 2 create intrinsics. Realm rec, the abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values newly object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform add restrict. Add function properties. Realm rec, return unused, 3.3 set realm global object, realm rec, global obj. This value, the abstract operation set realm global object takes arguments realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called if global obj is undefined. Then, A. Let intrinsics be realm rec. B. Set global obj to ordinary object create, intrinsics, assert. Global obj is an object if this value is undefined. Set this value to global obj, set realm rec to global obj, let new global env be new global environment, global obj, this value, set realm rec to new global env, return unused, 3.4 set default global bindings, realm rec, the abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called let global be realm rec. For each property of the global object specified in clause 19, do A. Let name be the string value of the property name. B. Let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4 the value of the attribute is the corresponding intrinsic object from realm rec. C. Perform. Define property or throw, global, name, desc, return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code.
There's already something called VK free.
In Table 25.
What's the difference between VK free and VK destroy?
Needed to
For fuck's sake.
of the code
I gotta rename my thing.
execution
Is there anything called VK delete?
view of this component is that function object. If the context
Everything's stupid.
the realm record from which associated code accesses ECMA script
Is there a call called VK new?
record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in first-out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component purpose. Lexical environment identifies the environment record used to resolve identifier references made by code with
So it's create, destroy, allocate, and free.
the environment record that holds bindings created by variable statements within this execution context. Private environment identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International
Command buffers, descriptor sets, memory.
27. Additional state components for generator execution contexts. In most
So it's get and release.
execution context, the top of the execution context stack is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module, 4.2 Resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined. and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. Env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called if env is not present or env is undefined. Then, A set env to the running execution context's lexical environment. Assert. Env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code. Let strict be true, else let strict be false. Return. Get identifier reference. Env name.
There's make macros for, I don't know, call them new, delete, alloc fray,
Documents and returns.
and get delete, release.
It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called let env be the running execution context's lexical environment too. Repeat. Component purpose. Generator the generator that this.
I'll like tag with object too.
156. ECMA International to
Click new object,
resolve by
delete object.
whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding, 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion contain on an ECMA script language a value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called let env rec beget this environment. Return env rec get this binding, 4.5 get new target. The abstract operation get new target takes no arguments and
I'll make one macro.
find. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called let env rec beget this environment. Assert. env rec has a field. Return env rec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called 2.5 let current realm be the current realm record. Return current realm, jobs and host operations to end with jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluated,
Alright, so
it must run to completion before
I'm going to
the job starts in an agent.
replace vk new with vk object.
Implementing its own handling of errors. ECMA ECMA International 2024-157. Note 1. Host environments are not required to treat jobs uniformly with respect to scheduling.
And pass in new as an argument and concat it.
Treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority at any particular time.
This way I can tell the objects apart from like the buffers, descriptors.
Or module if all of the following conditions.
This way might make it slightly easier. And then that way, anything that's object related, based on what they define as an object or whatever,
Execution
they'll all start with object, followed by the keyword to indicate do, delete, whatever.
module at any particular time. An execution is
And then I can use new and free.
script T-code if all of the following conditions are true. The execution context stack is not empty. The
Instead of alloc, because that's like
text on the execution context
alloc, malloc, kalloc,
additional
xalloc. There's like so many different ways to use alloc.
record is a record value.
In capital, new
Function objects that are invoked by
is more easier to read. I don't know.
and context to propagate the state.
So if I replace these first
Feature and call function.
to this, make sure this works.
Instead, use host make job callback and host call job callback. Job callback records have the fields listed in table 28. Table 28. Job callback record fields, 5.2 host make job callback. Callback. The host-defined abstract operation host make job callback takes argument callback. A function.
Alright, so it's easier to read. It's like VK object, new object, it's an image.
Conform to the following requirements.
And then it's a device, image info, null, and then handle.
Environments may prepare an execution to evaluate code by pushing execution contexts onto the execution.
So I don't have to memorize.
The specific steps are in
Like create destroy relates to objects, and allocate free relates to buffers, descriptor sets, memory.
and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWGHTML specification, https://html.spec.whatwg.org, for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host defined, anything default value is empty. Field reserved for use by hosts. 158, ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation.
Now I gotta get back to the documentation.
Job callback. A job callback record. V. An ECMA script language value and arguments list.
Finish this crap up.
Language value.
Slips garbage.
Returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert. Is callable. Job callback. Is true. Return. Call. Job callback. Callback. V. Arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job. Job. Realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering.
Alright, so concat times 3.
Generic job must conform to the requirements in 9.5, 9. 5. 5 host enqueue promise job. Job. Realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closure
Times 4 also. Up to 6.
or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation defined steps such that execution is prepared to evaluate ECMA.
That's 6.
Jobs invocation. Let script or module beget active script or module. At the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024-159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm
I gotta focus, get stuff done. I'm so bored. So object, concat times 3, macro helper object,
user ECMA.
go concat new, or delete whatever the keyword is,
For example,
followed by whatever the last token is.
WHATWGHTML
Theoretically,
https://html.spec.
run and build and check.
For example, uses realm to check for the ability to run script and for
Nope.
https://html.spec.whatwg.org entry.
Guys are flipped around.
6 host enqueue timeout job. Timeout job. Realm. Milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enqueue
Wait, what am I doing?
conform to the requirements in 9.5, 9.6 initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It steps when called let realm
I want to glue this with this and then pass this in last.
context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new
This is the payload
context is now the running execution.
to be concated to the macro that's concatting.
Global be such an object.
Not the concat, yeah.
Wise. Let global be undefined, indicating that an ordinary
And these had to be updated to 2 because it changed the name.
host requires that the this binding in realm's global scope return an object other than the global object. Let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, 0. Let set default global bindings, realm 1. Create any host-defined global object properties on global obj 2. Return unused. 0.7 agents. An agent comprise is a set of ECMA script execution contexts, an execution context stack, a running execution context, an agent record, and an executing step for the executing thread. The constituents of an agent belong exclusively to that agent. An agent's executing thread executes
Come on.
contexts independently of other agents.
I don't want to be doing this. I don't even want to be streaming.
Executing thread by multiple agents, provided none of the agents sharing the thread have an agent.
I just want to be done.
Note 1: some web browsers share a single executing thread across.
I literally have to stream it because nobody's gonna believe me.
Copyright sign, ECMA International 2024. While on
Only fucking reason.
rhythmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent record S fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29, agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithms get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block, a boolean, determines whether the agent can block or not. Signifier, an agent signifier, uniquely identifies the agent within its agent cluster. Is lock-free 1, a boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2, a boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8, a boolean, true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The
Paste this stuff back carefully.
also
Update it.
choices that can vary over time and between ECMA script implementations. There is no field.
Place these first. I am so tired of this already.
Operation is implemented with any type of lock. The operation
This will make it easier to tell the difference between things. So just whatever.
bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size
Like distinguishing objects from command buffers, descriptor sets, memory.
specifically, non-atomic accesses may still be performed.
I just don't care. I'm not gonna memorize, create, and allocate.
Shared memory and write shared memory.
And that's way too much to type. Create, destroy.
24161
I'm typing the whole word. Allocate. Holy fuck.
correspond to any particular artifact of an ECMA script implementation. 7.1 agent signify
So use these short, sweet macros to replace it.
an agent signifier. It performs the following steps
So it's more readable. Get done quicker.
surrounding agent
I just want to be done with this. I'm so tired of this.
and suspend. The abstract operation agent
It's taking way too fucking long.
and returns
Stupid API is trash.
following steps when called. 2.8 let AR be the agent recorder.
It's not absolute trash. Not everything's trash.
Some environments it may not be reasonable for a given agent to suspend. 4. Example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, It must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1 programs within different agents may share memory by unspecified means.
Maybe I should name these
Backing memory for shared array buffer.
JV instead of VK.
There may be agents that can communicate by message passing that cannot share memory.
For like John and Vulcan, I don't even know.
Need not all.
So I name it VK.
If agent A creates another agent B, after which A terminates and B creates agent C, the 3 agents are in the same
Or not. As long as nothing else is named VK with that, it should be fine.
within an agent cluster have different
Because it does directly call their API.
byte data. 62. Copyright sign. ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because,
So go like object, mem,
example, if an
or det, maybe for data.
time independent of documents in any windows were allowed to share memory
Like data, new.
an independent document, and the document and its dedicated worker were to be deactivated
What do I call get set?
once a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire
Extension,
the shared worker will be blocked until the dedicated work,
ext,
if ever. Meanwhile, other workers trying to access the shared work
so ext, I have get,
not be possible to share memory between agents that don't belong to the same suspend wait collective within the embedding.
I'll do like gcvk or vk extension, get,
Knowledge or cooperation. If a
whatever the extension is.
programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of 2 strategies. Either terminate all the agents in the cluster, or provide
Image memory requirements.
agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination. With the termination data containing enough information
Then vk,
that was terminated,
data and object.
specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waiter list record. Prior to any evaluation of any ECMA script code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial action declaration, a sync-generated declaration, and variable declaration.
Oh, this is so stupid. So create goes to objects.
An object.
Find object. I look for vk create.
May provide any ECMA script object value. Declarative record. A. Declarative environment record. Contains bindings for all declarations in global code for the associated realm.
Huh.
And declaration. Generated declaration.
That was nothing. Oh, did I spell v? I just spelled create wrong.
Declaration. And variable declaration bind.
Oh, I removed them all.
List of strings. The string names bound by function declaration. Generated declaration. A sync function declaration, a sync generated declaration, and variable declaration declarations in global code for the associated realm. ECMA International 2024, 43, Table 21, additional methods of global environment records. Method, purpose, get this binding, return the value of this environment records this binding, has a declaration, N, determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generated declaration, a sync function declaration, or a sync generated declaration, has lexical declaration, N, determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property, N, determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare global var, and if a corresponding create global var binding call would succeed if called for the same argument, N, can declare global function, N, determines if a corresponding create global function binding call would succeed if called for the same argument, N, create global var binding, N, D, used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding.
Do I do free? Delete.
Create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate. String value n is the bound name. B is the initialization value. If the Boolean argument D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following.
I don't know.
1. 4. 1 has binding. N.
My OCD says 3 letters are better.
The NVREC takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if the argument identifier is one of the
This doesn't line up quite as well.
forms the following steps when called. Let DCLREC be ENVREC. If DCLREC has binding, n is true.
I'm gonna do free. I'm not gonna do
OBJREC has binding, n, 1, 1, 4, 2 create mutable binding, n, D, the
that defeats the whole point. To give them different names.
n,
I'm both free.
n, a string, and D, a Boolean, and returns either a normal
Okay, so this I think might be more readable.
new mutable binding for the num n that is uninitialized. The binding is created in the
Or well, it will. That's why I'm wasting my time doing this.
ASMR International 2024 declarative record. A binding for n
So it's not actually a waste of time.
record. If D is true, the new binding is marked as
And I'm trying to think ahead on other things, so it's thinking time.
rec BENVREC. If DC
I think I might have to make a whole browser
throw it,
and just destroy V8.
create mutable
Not bother to sell the engine.
E, 1.
Just make a whole fucking browser.
3. Create a mutable binding. N, S. The create immutable binding concrete method of a global environment record ENVREC takes arguments n, a string, and s, a Boolean, and returns either a normal
And by destroy, I mean compute.
new immutable binding for the num n that is
It's the only way to win.
binding must not already
Is to slowly
record for n. Strict binding.
win from the bottom until it's total win.
ELREC BENVREC.
You can't just like eliminate the other side. That defeats the whole point.
Type error exception. Return.
Let's be slow. Drag it out
Binding. N, V.
until the competitor just can't make it.
Arguments n, a string, and V, an ECF.
Because that's what companies do when they like, well, not really.
Containing unused store throw completion.
How'd they take out,
The bound value of the current binding of the identifier whose
what was it? Voodoo video cards?
binding for n must already exist.
How did NVIDIA?
Steps when called. Let DCLREC be ENVREC. If DCLREC has binding, n is true, then a return. DCLREC initialize binding, n, v, assert. If the binding exists, it must be in the object environment record. Let OBJREC be ENVREC. Return. OBJREC initialize binding, n, v, 1, 1, 4, 5 set mutable binding, n, v, s. The set mutable binding concrete method of a global environment record ENVREC takes arguments n, a string, v, an ECMA script language value.
So I'm asking Chatbot, how did NVIDIA and whoever else take out Voodoo video card company via marketing and pricing products?
Binding of the identifier whose name is n to the value v if the binding is an immutable binding.
That made the
Thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined.
That's what do you spell voodoo?
DCL.
Whatever.
DCL rec has binding. N is true. Then A return.
2D acceleration, 3D acceleration.
V S. Let obj rec be env rec. Return. Obj rec set mutable binding. N V S, 1 1 4 6 get binding value. N S. The get binding value concrete method of a global environment record EN.
Says that's a great historical rabbit hole. I gotta stay out of rabbit holes. Stand track.
Turns
The 3DFX Voodoo era was a turning point in graphics history.
or a throw.
Let me lay out how NVIDIA and is ATI. They were what, bought by? I think ATI was bought by.
Then normally already exist.
Oh, what the fuck?
Not currently writable. Determined by S. It performs the following.
AMD
ENV
and displaced 3DFX in late 1990s.
N is true.
3DFX early dominance Voodoo Graphics 1986 and Voodoo 2 1998 for game-changing best 3D acceleration glide application strong developer support. But 3DFX boards were often 3D only. You still needed separate 2D card until the Banshee and Voodoo 3 came out.
4
This gave competitors room to attack with integrated 2D plus 3D solutions.
environment
Strategic mistake by 3DFX. Vertical integration. 3DFX acquired STB systems, board manufacturers in 1998 with results, owned branded product cards, and aligned with third-party boards, Diamond, Creative, etc.
following steps when
This alienated all third-party boards, Diamond, Creative, etc., who then turned to NVIDIA and ATI.
DCL rec delete.
NVIDIA stuck to fabless chip designs and let board partners do the manufacturing,
Has own property. Global
so it scaled much faster.
existing prop is true. Then A let status be. Delete binding. N B if status is true and EN.
Ah,
Then I remove N from ENV rec C return status. Return true. Comma.
so NVIDIA still sells things with their board or whatever, but they also... Okay, that makes sense.
Takes no arguments and returns true.
Like you get like a PNY NVIDIA,
1 4
I think. Yeah, PNY, whatever brand that is. It's an NVIDIA card, but it's not really NVIDIA, it's by P&D or something. So a third party could remake the NVIDIA card,
object. The with base object
so you don't get the quality of the company. But NVIDIA is crappy quality anyways.
concerns and defined.
That's why they had to sacrifice quality of control
1
when competing with Voodoo 3DFX video cards.
environment record ENV rec takes no arguments and returns a normal completion containing an object. It performs the following steps when called return ENV rec 146 ECMA International 2024. Note, global environment
So this video card was quality.
global environment
You get what you pay for.
ending 9
And NVIDIA competed by making sure like outsource the board or whatever. Because this one you get the board with the chips on it.
determines if the argument identifier
So they make it in-house. Except NVIDIA,
statement or a function
they outsource it.
performs the following steps when called let var declared names be env rec. If var declared names
So you get like a PNY, NVIDIA, what's another one?
1 4 1 3
MSI, NVIDIA,
has lexical declaration
whatever fucking brand.
record env
What's
a string.
Asus? Do they make NVIDIA?
It determines if the argument identifier has a binding in this record that was created.
The Asus, NVIDIA, they're all technically NVIDIA, except the quality of the board, the components other than the chip, depend on the company.
env rec return. DCL rec has binding.
That's why NVIDIA is shit.
1 4 has restricted global property. N that has restricted global property concrete.
So you can get different companies, different brands with the same shitty NVIDIA card on it.
Meaning a Boolean
But if you want like the Voodoo 2 back then or Voodoo 3 whatever,
identifier is the name of a
they'd make the board with the chip, so it had total control of the product. I don't know,
BJ
like above subpar.
object BO
NVIDIA though, they're like subpar, the bottom of the barrel.
existing prop is undefined.
They make shit,
If existing prop is true, return false.
and they overprice it as fuck.
Of April 2015 can declare global var. N. The can declare global var concrete method of a global environment record env rec takes argument n a string.
NVIDIA stuck to fabless chip design and the board partners do the manufacturing, so it scaled faster.
Determines
Slow tech evolution. Voodoo 3 was basically iteration. Still fixed function, lacked features like 32-bit color, large texture support.
existing global object.
NVIDIA Riva TN2 had.
The following steps when called let obj rec benv rec. Let global object bobj rec. Let has property.
What's this card look like?
Global object n if has property is true. Return true. Return is extensible. Global object
Wow, did they just copy?
rather than being declared using a var or function declaration. A global lexical binding may not be created that has
Is that an x86 CPU?
the global property undefined is an example of such a property. ECMA International 2024 147 9 1 1.
Or like,
Declare global function n that can declare global function concrete method of a global environment record env rec takes argument n a string and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called let obj rec benv rec. Let global object bobj rec. Let existing prop be global object
1, 2, 3, 4.
is undefined. Return is extensible. Global object if existing prop is true. Return true if is data descriptor.
So this one has higher density.
True and existing prop has
ROM or RAM, whatever you want to call it.
memorable. True. Return true.
ROM isn't actually always read-only.
7 create global var binding.
I don't know, ROM, RAM, whatever it is. It's definitely not SD flash.
NV rec takes arguments n a string and e.
So I'm pretty sure NVIDIA Rita TNT was slower.
Store a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list.
Then,
Lists. It is
I gotta not get distracted.
initialized. It performs the following steps when called let obj rec benv rec. Let global object bobj rec. Let has property b. Has own property. Global object.
Says 3dfx push glide, but Microsoft Direct 3D and OpenGL matured quickly, removing the need for proprietary APIs. Oh, really? But we still need proprietary APIs. Just like this fucking Vulkan API.
Undefined.
Damn, I lost my page.
Not contain n. Then a append. 7. Return unused. 1 1 4.
Developers shifted to a vendor-neutral standard.
V D. The create global function binding
NVIDIA's winning strategy,
environment record
marketed as world's first GPU. While it's hilarious,
a script like
even if it wasn't,
a boolean.
the branding stuck and developers adopted. Wow, they're pieces of shit. It's just like AI saying, we're the first artificial intelligence.
In the associated object
And the developers adapted quick,
bound name in
and the branding sticks.
if a binding already exists, it is 2.
By not manufacturing boards themselves, NVIDIA let Asus, MSI, LEDTech, Creative, etc. compete, lowering prices, increasing availability.
JREC
Pricing. NVIDIA offered scalable chips at multiple tiers.
or existing prop is true. Then a let desk be the property descriptor. V true.
3dfx had fewer SKUs and relied on a big, hot, multi-chip cards that were expensive.
Property or throw. Global object. N desk. Perform. Set.
Big, hot, multi-chip
Does not
because it's superior.
dependent env
It actually did something.
48. ECMA International 2024. Note global function declarations are always represented as own properties of the global object. If possible.
By 2000, NVIDIA hit the GeForce 2 8 Radeon. 3DFX was still struggling. Edition 45s.
The initialize bind
The company's burning cash, lost OEM deals, and alienated its board partners.
of proxy trap calls, comma 1.
NVIDIA absorbed the tech, but more importantly, removed its rival from the market.
Is a declarative environment record that is used to represent the outer.
Absorbed the tech. That's funny.
In additional to normal
Pieces of shit.
bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms, 1, 5, 1 get binding value, n, s, the get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language a value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called assert. S is true, assert. envrec has a binding for n. If the binding for n is an indirect binding, then a let m and n2 be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value. N2 true. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note S will always be true because a module is always strict mode code.
So the Voodoo 2, 3, whatever, were more GPU based.
The delete binding concrete method of a module environment record is never used within this specification.
Alright, so the Voodoo 3, overall performance, treated blows, blah blah blah, fell behind.
In a module environment record.
So whatever Glide was, that API, so dominated Glide based, which often ran faster and with less CPU overhead. Generally superior for OpenGL games and modern DirectX titles. Games cannot be played natively. Maxed out at 16-bit color, though it used proprietary dithering filter to make it appear closer to 22-bit. Could render in 32-bit color, though performance was significantly slower than 16-bit mode. So really it's like a 16-bit, but they made it do 32-bit.
5, 3 has this binding.
Limited to maximum texture resolution of 256 by 256 pixels.
No arguments and
supported larger texture sizes, which offered sharper and more detailed images in games designed to leverage this feature. But it ran slower. So excellent performance on slower CPUs due to the efficiency of the Glide API. Performance scaled better on faster CPUs, often surpassing the Voodoo 3 speed with the Pentium 3. That is a shitty processor, running over 500 MHz. So performance scaled faster on faster CPUs with NVIDIA video card, because it's not just the video card, it's a fucking CPU. So 3DFX was more actual GPU based, where the GPU did the rendering. NVIDIA relied on the CPU. That's why performance scaled better on faster CPUs, because it wasn't all GPU based. And now there's so much shit on the CPU. It's just fucking annoying. It's not even a fucking GPU at this point. there's so much shit going on the CPU that like, yeah, I don't know, whatever. It's fucking stupid.
Operate upon environment records.
So like, if the fucking NVIDIA, whatever TNT, whatever it was, if it didn't have a fast enough CPU, then it runs slower. So it's not fully GPU based.
And strict. A Boolean.
It relies on the fucking CPU because it's bottlenecked.
Containing.
This one has less bottleneck because it doesn't rely on the CPU doing the work. While NVIDIA's card, GPU, whatever, the TNT, whatever it is, relied on the CPU. Even though it's a GPU, the CPU had to do the work.
Name. If exists is true, then A return the reference record. env name strict empty else 150 ECMA International 2024. Note: module environment records.
This is low CPU overhead.
B let outer be env return get identifier reference outer name strict 9 1 2 to new declarative environment. The abstract operation new declarative environment takes argument
What is the CUDA cores?
and record or null and returns a declarative environment record. It performs the following steps when called. Let env be a new
So CUDA cores are like
containing no byte.
freaking CPU based or something.
Return env, 1, 2, 3 new object environment. OWE. The abstract operation new object environment takes arguments O, an object, W, a Boolean, and E, an environment record or null, and returns an object
So CUDA cores inside, it executes GPU threads.
called let env be a new object environment record.
The CPU schedules work on the GPU and it launches CUDA kernels,
Return env
manages memory transfers,
on new function.
but the CUDA cores live on the CPU die,
The
not the CPU. The CPU cannot execute CUDA code, it only orchestrates it.
and new target, an object or under
CUDA cores access GPU memory to interact with system RAM. Data must be copied across PCIe bus or accessed with unified memory,
containing no binding.
but still using GPU cores for execution.
Set env
Think of the CPU as a manager, CUDA cores as the factory floor.
to new
The manager tells the workers the task to perform.
1,
The CPU is the manager.
G
What's the point of the GPU if the CPU is a fucking manager? For fuck's sake.
returns a global environment record. It performs the following steps.
So I'm gonna ask you about this.
The new
I'm gonna say this,
G false.
where it says, think of the CPU as a manager and the CUDA cores as a factory floor of workers.
New global
I'm gonna ask, is it the GPU, not the manager?
to this value. Set env to D.
The GPU cost how much?
Set env to null. Return env, 1, 2,
And it ends up being bottlenecked with the CPU being the manager of the GPU? Question mark.
and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env. ECMA International 2024 151 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in a CMA script code. They are similar to, but distinct from, environment record.
So saying it ends up being bottlenecked with the CPU as a manager when the GPU is fully capable of accessing
Such a class is evaluated
the memory on the motherboard RAM independently of the CPU.
by that class. Each private environment record has the fields defined in table
So it's NVIDIA, again, being cheap, cutting corners,
field name, value type,
putting the workload on the CPU because their GPUs are crap, they're total shit.
record of the nearest containing class null if the class with which this private environment record is associated is not contained in
There's no reason their shit costs so much money other than the fact that it's crap.
2. One private environment record operation.
It says, now you're hitting the subtle distinction between CPU, GPU, and memory orchestration.
Records.
CPU runs operating system, application code, schedules, GPU work, commands, memory buffers over PCIe. Acts as a manager in a sense that the GPU doesn't automatically know what to do. It waits for instructions from the CPU. So in your analogy, CPU's manager issuing tasks, GPU factory with CUDA cores. GPU can also have sub-managers internally. Schedules inside GPU hardware that assign threads to the CUDA cores. Bottleneck possibility, even if the GPU is fully capable. PCIe transfer limits moving data between system RAM and GPU RAM slower than GPU memory bandwidth. CPU scheduling, launching kernels, setting parameters, and syncing results requires CPU involvement. Driver overhead, CPU calls, CUDA, blah blah blah. This is why in very high performance workloads the CPU can become a bottleneck even if the GPU has thousands of free cores. GPU can't access VRAM fully, independently. It does not freely access motherboard RAM without CPU orchestration, except in unified memory modes, which are still mediated by the CPU. Are not fully autonomous managers. The CPU sets the workflow.
A realm is represented in this specification as a realm record with the fields specified in Table 20.
I don't believe that.
Copyright sign, ECMA International 2024. Table 24. Realm record fields. Field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal, parse node, and v, an array, f, the agent that owns this realm, the global object for this realm, the G, global environment for this realm, meaning, the intrinsic values used by code associated with this realm, a list of records, with fields are, a string, and a module record. Note 1: once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2: as mentioned in host load imported module 16.2.1.8. Note 1: in realm records is only used when running an import expression in a context where there is no active script or module field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9.3.1 create realm. The abstract operation create realm takes no arguments and returns a realm record.
This GPU can access system RAM via PC only through IOMMU. DMA controller, not by touching CPU MMU directly.
Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9.3. 2. Create intrinsics. Realm rec.
So it needs to be copied.
Intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in Table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function steps. Length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the
I'm gonna get back on track.
is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal
Everything is just so dumb.
is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform add restrict. Ed function properties. Realm rec. Return unused. 3.3 set realm global object. Realm rec.
So Voodoo 3 is on the left.
The abstract operation set realm global object takes arguments realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called if global obj is undefined. Then, A. Let intrinsics be realm rec. B. Set global obj to ordinary object create. Intrinsics assert. Global obj is an object
The NVIDIA is like missing.
defined. Set this value to global obj. Set realm rec to global obj. Let new global en
Like everything.
global obj. This value. Set realm rec to new global
Like the lightning on the right hand side.
default global bindings. Realm rec. The abstract operation set
There's lightning there
takes argument realm rec
on the Voodoo 3.
and returns either a normal completion
But on NVIDIA,
it
there's no lightning at all.
realm rec for each
But you get like 32-bit color
clause 19. Do a let
on the NVIDIA.
view of the property name
But it still looks like
calculated data.
it's not 32-bit color. If anything, the left has better color than the right.
The properties listed in 19.2, 19.
Okay, maybe they both get lightning. Okay, it's a stupid demo.
Bonding intrinsic
It's not the same exact code that's running.
define property or throw global name desk return global point for execution.
50 FPS, that's weird.
Execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this
Oh, I'm so bored.
running execution context of the
I gotta get stuff done.
The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the
I mean, these demos are ghetto.
with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context
Is he testing this on a modern computer?
is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state
It's an Athlon.
track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State component.
How are you supposed to compare it if he speeds it up like that?
Component. Purpose. Code evaluation state. Any state needed to perform. Suspend. And
I
resume
can't even tell.
the code associated with this execution context. Function. If
So Doom,
context is a
84 and 60 frames.
object, then the value of
Well, I think that's because it's like designed for Doom,
context,
or Doom was designed for Voodoo.
script or module.
I'm really bored.
The realm record from which associated code accesses ECMA script resources, script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended.
So 60 frame press, or 60 something on Voodoo 2, 49 on NVIDIA, whatever.
A different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution
And now the video's not loading up.
execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among
So on this one, 43 NVIDIA,
last in first out manner. However, some ECMA script features require non-LIFO transitions of the running execution context.
Voodoo 3 is 52, so the Voodoo 3 is faster
Execution
than NVIDIA.
or the current realm record. The value
Alright, I gotta like focus and get done.
context is is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component. Purpose. Lexical environment. Identifies the environment record used to resolve
This.
in this execution context. Variable environment identifies the environment record that holds bindings created by variable statements.
I don't know, really. It's just as confusing to read.
Environment identifies the private environment record that holds.
So now it's more clear that these are objects, or what they consider an object in the API.
The lexical environment
I think I have to do delete
components of an execution context are always environment
just to make it the same length.
representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27.
I can't though, I gotta do free.
Generator execution contexts. In most situations, only the running
So this is just as difficult to read as this.
context stack is directly manipulated by algorithms within this specification. Hence, when the terms lexical
Now I can do object, new free, data, new free, I don't know, whatever.
in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module, 4.2 Resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name env can be used to explicitly provide the environment record that is to be searched for the binding.
Alright, so I gotta get this mech one place.
env is not present or env is
I gotta like find a place, get this stuff done.
execution context's lexical environment.
Back to documentation and then
An environment record. If the source text matched by the syntactic production that is being evaluated,
find all the stuff related to like making this quad.
let strict be false. Return. Get
Because it's not just like an object. The quad consists of several different freaking parts.
abstract operation
So it's like an object,
takes no arguments and returns an environment.
but there's a whole bunch of different parts. So really, for the API to call it an object is kind of misleading.
Following steps.
It's like parts of an object. The whole object itself
Environment.
is never really an object. It's always like parts that make up the object,
This execution.
which is annoying as hell.
156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env has this binding. If exists
I need some more water. Alright, I'm gonna like get this stuff done.
outer is not null. Set env to outer.
No more rabbit holes, distractions, stand track.
List of environment
Or try.
with the global environment which has this binding, 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion contain on an ECMA script language a value or a throw completion. It determines the binding of the keyword thus using the lexical environment of the running execution context. It performs the following steps when called. Let envrec beget this environment. Return envrec get this binding, 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let envrec beget this environment. Assert envrec has a field. Return envrec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 let current realm be the current realm record. Return current realm, jobs and host operations to enquire jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enquire generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enquire promise job and host enquire timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024-157. Note 1 host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority at any particular time. Script or module. A script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module. Is script or module. If script or module is a script record or module record, let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMA script code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enquire by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields, 5.2 host make job callback. Callback. The host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note 2 host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158, ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, V, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert. Is callable. Job callback. Is true. Return. Call. Job callback. Callback. V. Arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job. Job. Realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5, 5 host enqueue promise job. Job. Realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script for module beget active script for module at the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script for module is the active script for module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for job when the realm is null, no user ECMA script code will be evaluated and no new ECMA script objects, for example error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses Realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org entry, concept, 5.6 host enqueue timeout job, Realm, milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job, a job abstract closure, Realm, a Realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by Realm to be performed after at least milliseconds. An implementation of host enqueue timeout job must conform to the requirements in 9.5, 9.6 initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called: let realm be create realm, let new context be a new execution context, set the function of new context to null, set the realm of new context to realm, set the script or module of new context to null, push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object, created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global, this value 0. Let global obj be. Set default global bindings, realm 1. Create any host-defined global object properties on global obj 2. Return unused. 0.7 agents. An agent comprise is a set of ECMA script execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60. Copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent record S fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields, field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithms get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block, a boolean, determines whether the agent can block or not. Signifier, an agent signifier, uniquely identifies the agent within its agent cluster. Is lock-free 1, a boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2, a boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8, a boolean, true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list. representing the list of objects and/or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMA script implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See read shared memory and write shared memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a Boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR. Agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. 4. Example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note to the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the 3 agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3. If different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign. ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wait collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of 2 strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination. with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waiter list record. Prior to any evaluation of any ECMA script code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial action declaration, a sync-generated declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generated declaration, a sync function declaration, a sync generated declaration, and variable declaration bindings. var names, a list of strings. The string names bound by function declaration, generated declaration, a sync function declaration, a sync generated declaration, and variable declaration declarations in global code for the associated realm. ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method, purpose, get this binding, return the value of this environment records this binding, has a declaration, n, determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generated declaration, a sync function declaration, or a sync generated declaration, has lexical declaration, n, determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property, n, determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare global var, n, determines if a corresponding create global var binding call would succeed if called for the same argument, n, can declare global function, n, determines if a corresponding create global function binding call would succeed if called for the same argument, n, create global var binding, n, d, used to create and initialize to undefine the global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding, n, v, d, create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 4, 1 has binding, n, the has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n, is true, return true. Let objrec be envrec. Return objrec has binding, n, 1, 4, 2 create mutable binding, n, d, the create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the num n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If d is true, The new binding is marked as being subject to deletion. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n is true, throw a type error exception. Return DCL-rec create mutable binding, n d, 1, 1, 4, 3 create immutable binding, n s. The create immutable binding concrete method of a global environment record env-rec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the num n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n is true, throw a type error exception. Return DCL-rec create a mutable binding, n s. For initialize binding, n v. The initialize binding concrete method of a global environment record env-rec takes arguments n, a string, and v, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n is true, then a return DCL-rec initialize binding, n v. Assert if the binding exists, it must be in the object environment record. Let obj-rec be env-rec. Return obj-rec initialize binding, n v, 1, 1, 4, 5 set mutable binding, n v s. The set mutable binding concrete method of a global environment record env-rec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n is true, then a return DCL-rec set mutable binding, n v s. Let obj-rec be env-rec. Return obj-rec set mutable binding, n v s, 1, 1, 4, 6 get binding value, n s. The get binding value concrete method of a global environment record env-rec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding is an uninitialized binding. Throw a reference error exception. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n is true, then a return DCL-rec get binding value, n s. ECMA International 2024 145 3. Let obj-rec be env-rec. Return obj-rec get binding value, n s, 1, 1, 4, 7 delete binding, n. The delete binding concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n is true, then a return DCL-rec delete binding, n. Let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be has own property, global object, n. If existing prop is true, then a let status be obj-rec delete binding, n. B if status is true and envrec contains n, then I remove n from envrec. C return status. Return true, 1, 1, 4. 8 has this binding. The has this binding concrete method of a global environment record envrec takes no arguments and returns true. It performs the following steps when called. Return true, 1, 1, 4. 9 has superbinding. The has superbinding concrete method of a global environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 4, 1, 0 with base object. The with base object concrete method of a global environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined. 9, 1, 1, 4, 1, 1 get this binding. The get this binding concrete method of a global environment record envrec takes no arguments and returns a normal completion containing an object. It performs the following steps when called. Return envrec. 146. ECMA International 2024. Note: global environment records always provide this binding. Note: global environment records do not provide a superbinding. 9, 1, 1, 4, 1, 2 has var declaration. N. The has var declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called. Let var declared names be envrec. If var declared names contains n, return true, return false, 1, 1, 4, 1, 3 has lexical declaration. N. The has lexical declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called. Let DCLREC be envrec. Return. DCLREC has binding n, 1, 1, 4, 1, 4 has restricted global property. N. The has restricted global property concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object. N. If existing prop is undefined, return false. If existing prop is true, return false. Return true, the 1st of April 2015 can declare global var. N. The can declare global var concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let has property b. Has own property, global object. N. If has property is true, return true. Return is extensible, global object. Note: properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147, 9, 1, 1, 4, 1, 6 can declare global function. N. The can declare global function concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object. N. If existing prop is undefined, return is extensible, global object. If existing prop is true, return true. If is data descriptor, existing prop, is true and existing prop has attribute values, true, enumerable, true, return false, 1, 1, 4, 1, 7 create global var binding, n, d, the create global var binding concrete method of a global environment record env-rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called: let objrec be env-rec, let global object be objrec, let has property b, has own property, global object, n, let extensible be, is extensible, global object. If has property is false and extensible is true, then a perform. Objrec create mutable binding, n, d, b perform. Objrec initialize binding, n, undefined. If env-rec does not contain n, then a append enter env-rec 7. Return unused, 1, 1, 4, 1, 8 create global function binding, n, v, d, the create global function binding can prep, e method of a global environment record env-rec takes arguments n, a string, v, an ECMA script language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8 replaced. It performs the following steps when called: let objrec be env-rec, let global object be objrec, let existing prop be global object, n, if existing prop is undefined or existing prop is true, then a let desc be the property descriptor, v, true, true, d, else, a let desc be the property descriptor, v, perform. Define property or throw, global object, n, desc, perform. Set, global object, n, v, false. If env-rec does not contain n, then a append enter env-rec. Return unused, 48. ECMA International 2024. Note: global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls, 1, 1, 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding, and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms, 1, 1, 5, 1 get binding value, n, s, the get binding value concrete method of a module environment record env-rec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called: assert, s is true, assert, env-rec has a binding for n. If the binding for n is an indirect binding, Then, A let m and n2 be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value. N2. True. If the binding for n in env rec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in env rec. Note S will always be true because a module is always strict mode code 9, 1, 1, 5, to delete binding. N. The delete binding concrete method of a module environment record is never used within this specification. Method purpose create import binding. N. M. N2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and N2 is a binding that exists in M's module environment record. Get this binding, return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note module environment records are only used within strict code, and an early error rule prevents the delete operator, in strict code, from being applied to a reference record that would resolve to a module environment record binding. C13. 5. 1, 1, 1, 1, 5, 3 has this binding. The has this binding concrete method of a module environment record env rec takes no arguments and returns true. It performs the following steps when called return true, 1, 1, 5, 4 get this binding. The get this binding concrete method of a module environment record env rec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called return undefined, 1, 1, 5, 5 create import binding, n, m, n2. The create import binding concrete method of a module environment record env rec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in M's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called assert. Env rec does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in env rec for n that references m and n2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9, 1, 2, 1 get identifier reference. Env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called if env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env, name, strict, empty. Else. 150. ECMA International 2024. Note: module environment records always provide this binding. AB let outer be env. Return get identifier reference. Outer name strict. 9, 1, 2. To new declarative environment. E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment O, W, E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called let env be a new object environment record. Set env to O, set env to W, set env to E, return env, 1, 2, 4 new function environment, F. New target. The abstract operation new function environment takes arguments f, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to f. If f is lexical, set env to lexical, else. Set env to uninitialized, set env to new target, set env to f, return env, 1, 2, 5 new global environment, g, this value. The abstract operation new global environment takes arguments g, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let obj be new object environment, g, false. Null. Let DCL-rec be new declarative environment. Null. Let env be a new global environment record. Set env to obj-rec. Set env to this value. Set env to DCL-rec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment. E. The abstract operation new module environment takes argument e, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to e. Return env. ECMA International, 2024 151, 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value type, meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names. The private names declared by this class. 9. 2. 1 Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy NV. The abstract operation new private environment takes argument outer privy NV, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy NV, names, 2, 1. 2 resolve private identifier. Privy NV, identifier. The abstract operation resolve private identifier takes arguments privy NV, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy NV. For each private name Pn of names, do A if Pn is identifier. Then, I return Pn. Let outer privy NV be privy NV. Assert. Outer privy NV is not null. Return resolve private identifier. Outer privy NV, identifier. Point 3 realms. Before it is evaluated, all ECMA script code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24, realm record fields. Field name, agent signifier, intrinsics, global object, global ENV, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records.
So now it's like clearly obvious
And V, an array, F, the agent that
that, because it's like object, new, image.
the
device, blah blah blah, is to be assigned to this handle. So you make a new thing,
Module record. Note 1.
and this is the handle.
Unreachable. The corresponding is also unreachable, and it would be unobserved.
So instead of calling like maillock or whatever,
Anything default.
the new call is just a wrapper.
Load imported module 16218 note 1 in realm records.
This API sucks.
Report. Expression in a context where there is no active script or module. Field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record.
When it's like this, it's like VK create image.
Same, 9.
Okay, what image, handle, I don't know.
Record. It performs the following.
This is like way more obvious to read than whatever.
Realm rec. Set realm rec to agent signifier. Set realm.
The GPU sucks also. It all sucks.
Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9.
So now it's easier to see. This is an object based on
And create intrinsics takes argument realm rec.
what they consider an object to be in the standard.
Used. It performs the following step.
And these are descriptors or whatever. It's data. It's not an object.
Table 6. The field names are the names listed in.
So VK bind.
Value of each field is a new object populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function steps. Length, name.
Is there an unbind? How do you unbind to something?
Steps is the definition of that function provided by this specification. Name is the initial value.
Well, that's confusing.
Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function
What the hell's a git call?
slots. And prototype is the specified value of the function's internal slot. The creation of the
So it doesn't make new memory, it just assigns it, I think, internally.
is upon objects that have
Instead of making the memory, it's like assigning, but it's not.
entities.
Is mem requirements an opaque handle?
3.3 set realm global object, realm rec, global OBJ, this value, the abstract operation set realm global object takes arguments realm rec, a realm record, global OBJ, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called if global OBJ is undefined. Then
The fuck is opaque?
realm rec, b set global OBJ.
Close enough.
Create, intrinsics, assert. Global OBJ is an object. If this value is undefined, set this value to global OBJ, set realm rec to global OBJ, let new global env be new global environment, global OBJ, this value, set realm rec to new global env, return unused, 3.4 set default global.
Bitfield and suitable memory types. Bitfield.
Default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called let global be realm rec. For each property of the global object specified in clause 19, do a let name be the string value of the property name, b let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4 the value of the attribute is the corresponding intrinsic object from realm rec, C perform.
Oh.
Global, name, desc, return global, point for execution contexts.
That's why it does one. Left shift I.
Device that is used to track the run evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code.
Hold on, is this expanding?
Execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running
So it's checking the bit field.
is the top element of this stack. A new
Looks like this, whatever.
created whenever
32 bits. Whatever bits set.
the currently running execution
Oh, this is some ridiculous way to write code. Holy fuck.
before
This is terrible.
ECMA International.
Oh, I hate everything. Everything is so stupid.
The newly created execution
For fucks, are you kidding me?
comes the running
Why don't they just return a list?
execution context contains whatever implementation specific state is
Return a list of indexes or take a bit field. Why don't they take a bit mask? Why can't you just set a bit, pass it in?
component.
Why do you have to expand it?
25 state
Oh, it's fucking dumb.
component purpose code of
Yeah, this API sucks. Never mind.
to perform suspension
They return a bit field
of the code
to be lazy
association context function. If this
because they're like,
is evaluating the code of a function object, the
otherwise you gotta like allocate more memory.
an object
So they compact it to a bit field
script or module. The value is
to save memory on their part,
code from which associated code accesses ECM,
so they don't have to deal with like making a list or making the structure really big.
which associated code originates. If there is
And it's up to the person using the API
this is the case for the original
to get the bit position from this value.
realm, the value is null. A value
Is there only one bit in this set?
may be suspended at various points defined within this specification. Once the running execution,
Describes the memory requirements of a buffer or image which you query
the running execution
via get buffer memory requirements or vk get buffer memory requirements.
context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended.
Used for planning memory allocation with vk allocate memory.
Execution contexts usually occurs in stack-like last-in, first-out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution context
Okay, why get one bit?
in Table 26. Table 26, additional state component
So the API is set up so you have to make allocations, pass it in,
purpose,
and they just kind of like compress that and pass it back.
and record used to resolve identifier references made by code within this execution context. Variable environment identifies the environment record that holds bindings created by variable statements within this execution.
So properties,
Identifies the private environment record that holds private names created by class elements in the nearest
so if the bit's set,
there is no containing class. The lexical environment and variable environment components of an execution
and
always environment records. Execution contexts representing
mem properties, what the fuck is that?
components listed in Table 27.
Oh, this macro is calling it again.
155. Table 27. Additional state components for
Oh my god, I'm pathetic. It's so dumb.
generating execution
Why?
of the execution context stack.
Yes.
Algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in
Passing in memory requirements.
execution
Dot type bits.
context
Physical device.
mechanism.
Properties.
ECMA script implement
What the hell is properties?
possible for ECMA script code to directly
It's passed in defined memory type.
context.
Is this a fucking bit field?
Active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to detect
Oh my god, there's so many fucking...
running execution context. It performs the following steps when called. If the execution context stack is empty,
It is a bit field.
be the topmost execution context on the execution context stack whose script or module
No wait, hold on, what the fuck? Properties, nothing even calls this.
return null. Otherwise, return X script or module, 4.2 resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called if env is not present or
Possible issue with globals and locals.
env to the running execute.
Staging buffer and image creations are temp or resident after func call.
If the source text match
I just turned off. I'm not using this function.
is contained in strict mode, code, let strict be true, else let strict be false. Return, get identifier.
So I'm not going to bother with it.
The name, strict, 4.3 get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently
So property host visible, property coherent.
the following steps when called
So that in the standard whatever,
lexical environment 2. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of
host and device.
whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be
That's not it.
assert. Out
Somewhere in here it said
v to outer. Note the loop in step 2 will always
it's visible
to the environment.
only to like the process, or not visible when accessed externally, or like it's only, or it's like on the heap. I don't know, fucking whatever.
And returns either a normal completion contain an ECMA script language a value or a throw completion. It determines the binding of the keyword thus using the lexical environment of the running execution context. It performs the following steps when called let envrec beget this environment, return envrec get this binding, 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined.
This is page I saw last time.
Using the
Alright, I'm gonna like,
running execution.
whatever.
It performs the following steps when called let envrec beget this environment, assert. envrec has a field, return envrec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It following steps when called 2.5 let current realm be the current realm record. Return current realm, jobs and host operations to enquire jobs. A job is an abstract closure with no parameters that initiates an ECMA script.
I'm gonna look up VK bind, what those say too.
Is currently in progress. Job
I want to wrap them with a macro wrapper like this one.
environments in
This makes it easier to fucking understand.
application describes the host hook's host enquire generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T.
So bind what? It means it's using existing allocations. It doesn't make opaque handles behind the scenes.
Promise job and host enquire timeout job.
Except you can't do it CPU side because it's up to the GPU to bind it. So that's what bind means, okay.
Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract.
Because bind in JavaScript means,
If a realm requires
yeah, this isn't JavaScript.
schedule the job
This is GPU programming.
in the agent that owns the
All this stuff makes, this API sucks.
does not evaluate ECMA script code. Their implementation
I don't know.
following requirements
It kinda sucks. It kinda doesn't. Everything sucks.
in the agent for which the job is scheduled and that agent's execution context stack is empty. The implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024-157. Note 1: host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority at any particular time. Script or module. A script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module. Is script or module. If script or module is a script record or module record. Let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMA script code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kind.
So I'm asking, this VK buffer memory, are they more VK behind prepended calls? And behind means that the GPU has to manage two resources, possibly opaque,
By the host may have additional
because it can't be done CPU side,
propagate the
or being why it can't be done CPU side, but called bind because no allocations are made,
callback job
uses only existing memory, or no, explain.
gate job callback record fields, 5.2 host make job callback. Callback, the host defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must
Says yes.
record whose field is callback.
VK bind are distinct from create or allocate.
Evaluate code.
Binding generally means associate a resource image buffer with a block of memory or another object.
This
But it's not really a fucking object.
environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG-HTML specification, https://html.spec.whatwg.org. For example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158, ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record. V. An ECMA script language value, and arguments list, a list of ECMA script language values. And return
So I'm saying, what the hell is an object?
ECMA script
It's like part. It's like a part
implementation of
that makes up the fully assembled blob.
it must perform and return the result of call. Job callback. V.
Normally an object is a complete thing, but there is no quad object. It's made up of several objects that belong to a descriptor.
Turn. Call. Job callback. Callback. V.
So I guess a descriptor
CMA
is a collection of objects.
must use the default implement.
If this terminology
Generic job.
is even the right word. Wow, this is pathetic how they name this shit.
Language generic job takes arguments job, a job abstract closure, and realm, a realm record and returns unused. It schedules job in the realm in the agent signified.
Is terminology the correct word to describe
Abstract closures used with this
the naming convention
constraints, such as
convention that was used
host enqueue generic job must conform to the requirements.
for the Vulkan API?
5 host enqueue promise job realm. The host defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm
The objects are like properties,
it schedules job to be performed at some future time. The this algorithm are intended
and the collection of properties is like a class, correct? Yes or no?
be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following.
And the collection of objects that are assigned to a descriptor
Form implementation defines steps such that
or bound or binded, whatever the fuck it is.
EMA script code at the time of job's invocation. Let script for module beget active script for module. At the time host enqueue promise job
That's more like
is not null.
a class.
Implementation must perform implementation defines steps such that script for module is the active script for module at the time of job.
Would it make sense to call them properties and class
Promise job
or family members?
Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024-159. Note the realm for jobs returned by new promise resolved thenable job is usually the
Alright, so I'm saying,
then function object.
is terminology the correct word?
Usually the result of calling get function realm on the handler
That or for this that describes
for both kinds of jobs. When get function realm completes abnormally,
to use for describing
realm is
the naming convention
get function realm call.
that was used for the Vulkan API. The objects are like properties and the collection of objects that are assigned to a descriptor that's more like a class. Would it make sense to call things properties, family members belonging to a class or not? Correct me, I'm just assuming.
//html.spec.whatwg.org.
Since I see exactly what you're grappling with, Vulkan's terminology is confusing. It's confusing as fuck.
htt
Because object in Vulkan doesn't mean the same thing as an object in OOP.
spec dot
C++, Java, let's break this down.
concept
Object is a handle. Well then call it a handle.
job realm
God damn. The naming is stupid as fuck.
job takes arguments timeout job a job abstract closure realm
VK buffer, VK image, VK shader module, VK pipeline.
finite num
Descriptor set layout. Each object is a self-contained in this sense that it represents something the GPU can track.
milliseconds. An implementation of host enqueue timeout job must conform to the requirements in 9.5, 9.6 initial
Key points, Vulkan objects can be handles, opaque, for, oh my god.
arguments and
Objects can be handles or structs.
pro completion.
This whole thing, this whole API could be totally rewritten. The whole thing.
The function of
This thing's a fucking joke. Who organized? This is terrible.
text to null. Push new context onto the
This is horrible.
stack. New context is now the running execution context.
Because VK device is a handle, but VK memory requirements is a struct.
Let global be
And then a handle is an object, but a struct is also an object.
defined, indicating
Objects can own other objects.
created as the global object. If
Well, that just, wow.
in realms global
Objects are minimal. They don't necessarily contain all their functionality internally.
object created in a host
Yet, because you need several objects to make a thing.
undefined, indicating that
It says you're right, an object is sometimes more like a part of a bigger system.
object
A quad in your renderer isn't a single Vulkan object. That's how you use the word object. Object usually means a single object, not a part of the whole.
Properties on
This is it uses VK buffer for vertex, VK buffer for indices, VK descriptor set for uniform textures, VK pipeline for drawing.
an
So that's what the pipeline is for drawing.
execution context, an agent record.
Descriptor set for textures.
Thread, the constituents of an agent belong exclusively to that
These components are objects. In Vulkan terminology is shit. Holy fuck.
text independently of other agents.
Together they make a logical unit. There's no logic to any of this.
Multiple agents
Like your quad. But the Vulkan doesn't give it a single handle.
through. Note 1
Which it should. And call it a fucking class. The fuck is this shit?
tabs of a browser window.
So thinking of objects as properties of parts belonging to a class is reasonable. It's the only way that programming is functional.
Executing
You have a thing that holds a thing, or you have a thing that holds things but is still a thing.
agent to
But calling it an object
a level execution object.
and a descriptor is like, what the fuck?
Execution context. The execution context stack
So what the hell does a descriptor hold?
fields and
Oh my god, an object holds descriptors?
you use to identify an agent. Table 29, agent record fields.
This whole thing is unorganized.
A boolean.
It's just,
Is little
it's literally just exposing the parts of the GPU function, the internal functions.
and should be the alternative.
I bet this shit maps directly to the fucking chips on the fucking GPU.
Change can block. A boolean determines whether the agent can block or not. Signifier, an agent signifier. Unique.
Because the GPU is made up of several chips, several different layers.
A boolean true if atomic
This piece of shit.
byte values are lock free. False otherwise. Is lock free too. A boolean true if atomic operations on 2-byte
I want machine code. This is horrible. I hate this.
create. A boolean true if atomic operations on 8-byte values are lock free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new
It says, so in your discussion, it's terminology, not naming convention, where you're reasoning about object. Okay, so terminology is the correct word to use.
any agent in the agent
Object equals property, part of a larger logical thing.
determined by the hardware.
Vulkan object, GPU tractor handled.
Choices that can
Quad or mesh is not a single object, a collection of objects.
implementation.
Thinking OOP terms is okay. Everything is object oriented,
Atomic
even when it's not.
with any type of lock, the operation is not lock free. Lock free does not
Okay, so descriptor set, pipeline, logical rendering unit.
steps may be required to complete a lock free atomic operation. That in a
Descriptor sets like a pipeline?
imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may
This is so confusing.
series shared memory and
What the hell's a logical render unit?
Rama International 2024
Use terminology to discuss this, not naming convention.
specification mechanism and need not correspond to any particular artifact of an EC
Oh great, it's a make a diagram. I wonder how great this will turn out.
signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier.
It's probably gonna suck.
Steps
Oh my god, it's wasting time on a photo.
the surrounding
Now I'm gonna run out of questions. Say you ran out of questions to ask it.
the abstract
Oh, this is so crappy.
and returns a boot.
Everything can suck a dick.
Following steps when called 2.8. Let AR be the agent record of the surrounding agent. Return AR agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. 4. Example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1 programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shader agents
It's gone for 2 minutes. It's still not done.
may be agents that can communicate.
This better be amazing. What the hell is it doing?
They are never in the same agent cluster. Note to the agents in a cluster some particular point in time.
It took 2 minutes
Other agent B, after which a terminate
to make this? Are you fucking kidding me?
cluster if A could share some memory with
That took 2 minutes.
C. Note 3 if different agents within an agent cluster have different values of it becomes hard to use shared memory.
It took 2 minutes to render that.
Copyright
2 entire minutes.
2020.
That's not even...
The preceding restriction is to avoid a situation where an agent deadlocks or starves because another,
I can make a diagram showing
for example,
Vulkan objects properties versus logical. So relationship between buffers, images, descriptors is crystal clear. Well,
document
that is crystal clear.
did worker were to be
It's probably not even right.
dated worker.
There's probably so many exceptions.
The document is pushed into its Windows history, and the shared worker
Oh, everything's so fucking stupid.
the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend wait collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination. With the termination data containing enough information to identify the agent that was terminated, each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waiter list record. Prior to any evaluation of any ECMA script code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial function declaration, a sync-generated declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generated declaration, a sync function declaration, a sync generated declaration, and variable declaration bindings. var names, a list of strings. The string names bound by function declaration, generated declaration, a sync function declaration, a sync generated declaration, and variable declaration declarations in global code for the associated realm. ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method purpose: get this binding, return the value of this environment records this binding, has a declaration. N determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generated declaration, a sync function declaration, or a sync generated declaration, has lexical declaration. N determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property. N determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare global var. N determines if a corresponding create global var binding call would succeed if called for the same argument. N can declare global function. N determines if a corresponding create global function binding call would succeed if called for the same argument. N create global var binding. N D used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N, V, D, create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. B is the initialization value. If the Boolean argument D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 4, 1 has binding. N, the has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n is true, return true. Let OBJREC be envrec. Return OBJREC has binding, n, 1, 4, 2 create mutable binding, n, D, the create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the num n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If D is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n is true, throw a type error exception. Return DCLREC create mutable binding, n, D, 1, 4, 3 create a mutable binding, n, S, the create immutable binding concrete method of a global environment record envrec takes arguments n, a string, and S, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the num n that is uninitialized. A binding must not already exist in this environment record for n if S is true. The new binding is marked as a strict binding. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n is true, throw a type error exception. Return DCLREC create a mutable binding, n, S, for initialize binding, n, V. The initialize binding concrete method of a global environment record envrec takes arguments n, a string, and V, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n is true, then a return DCLREC initialize binding, n, v. Assert. If the binding exists, it must be in the object environment record. Let OBJREC be envrec. Return OBJREC initialize binding, n, v, 1, 4, 5 set mutable binding, n, v, s. The set mutable binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let dclrec be envrec. If dclrec has binding n is true, then a return dclrec set mutable binding n v s. Let objrec be envrec return objrec set mutable binding n v s, 1 1 4 6 get binding value n s. The get binding value concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language a value or a throw completion. It returns the value of its bound identifier whose name is n if the binding is an uninitialized binding. Throw a reference error exception. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let dclrec be envrec. If dclrec has binding n is true, then a return dclrec get binding value n s. ECMA International 2024 145 3. Let objrec be envrec return objrec get binding value n s, 1 1 4 7 delete binding n. The delete binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called let dclrec be envrec. If dclrec has binding n is true, then a return dclrec delete binding n. Let objrec be envrec. Let global object be objrec. Let existing prop be has own property global object n. If existing prop is true, then a let status be objrec delete binding n. B if status is true and envrec contains n, then I remove n from envrec. C return status return true, 1 1 4 8 has this binding. The has this binding concrete method of a global environment record envrec takes no arguments and returns true. It performs the following steps when called return true, 1 1 4 9 has super binding. The has super binding concrete method of a global environment record envrec takes no arguments and returns false. It performs the following steps when called return false, 1 1 4 1 0 with base object. The with base object concrete method of a global environment record envrec takes no arguments and returns undefined. It performs the following steps when called return undefined 9 1 1 4 1 1 get this binding. The get this binding concrete method of a global environment record envrec takes no arguments and returns a normal completion containing an object. It performs the following steps when called return envrec. 146 ECMA International 2024. Note: global environment records always provide this binding. Note: global environment records do not provide a super binding. 9 1 1 4 1 2 hasvar declaration n. The hasvar declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called let var declared names be envrec. If var declared names contains n, return true, return false, 1 1 4 1 3 has lexical declaration n. The has lexical declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called let DCL-rec BENV-rec return. DCL-rec has binding n, 1, 1, 4, 1, 4 has restricted global property n, the has restricted global property concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called let objrec BENV-rec, let global object be objrec, let existing prop be global object, n, if existing prop is undefined, return false. If existing prop is true, return false, return true, the 1st of April 2015 can declare global var. N, the can declare global var concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called let objrec BENV-rec, let global object be objrec, let has property b, has own property, global object, n, if has property is true, return true, return, is extensible, global object. Note properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147, 9, 1, 1, 4, 1, 6 can declare global function, n, the can declare global function concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument and it performs the following steps when called let objrec BENV-rec, let global object be objrec, let existing prop be global object, n, if existing prop is undefined, return, is extensible, global object, if existing prop is true, return true, if is data descriptor, existing prop, is true and existing prop has attribute values, true, enumerable, true, return false, 1, 1, 4, 1, 7 create global var binding, n, d, the create global var binding concrete method of a global environment record env-rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called let objrec BENV-rec, let global object be objrec, let has property b, has own property, global object, n, let extensible be, is extensible, global object, if has property is false and extensible is true, then a perform. Objrec create mutable binding, n, d, b perform. Objrec initialize binding, n, undefined. If env-rec does not contain n, then a appendent to env-rec 7. Return unused, 1, 1, 4, 1, 8 create global function binding, n, v, d, the create global function binding can crep, e method of a global environment record env-rec takes arguments n, a string, v, an ECMA script language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8 replaced. It performs the following steps when called let objrec BENV-rec, let global object be objrec, let existing prop be global object, n, if existing prop is undefined or existing prop is true, Then, A, let desc be the property descriptor. V, true, true. D, else. A, let desc be the property descriptor. V, perform. Define property or throw, global object, N, desc. Perform. Set, global object, N, V, false. If envrec does not contain N, then A append enter envrec. Return unused. 48. ECMA International 2024. Note global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls. 1. 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding, and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms. 1. 5. 1 get binding value. N. S. The get binding value concrete method of a module environment record envrec takes arguments N, a string, and S, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is N. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called assert. S is true, assert. envrec has a binding for N. If the binding for N is an indirect binding, then A let M and N2 be the indirection values provided when this binding for N was created. B let target env be M. C if target env is empty, throw a reference error exception. D return target env get binding value. N2, true. If the binding for N in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to N in envrec. Note S will always be true because a module is always strict mode. Code 9, 1, 5, to delete binding. N, the delete binding concrete method of a module environment record is never used within this specification. Method, purpose, create import binding. N, M, N2, create an immutable indirect binding in a module environment record. The string value N is the text of the bound name. M is a module record, and N2 is a binding that exists in M's module environment record. Get this binding, return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note module environment records are only used within strict code, and an early error rule prevents the delete operator, in strict code, from being applied to a reference record that would resolve to a module environment record binding. C13, 5, 1, 1, 5, 3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called return true, 1, 5, 4 get this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called return undefined, 1, 5 create import binding. N, M, N2. The create import binding concrete method of a module environment record envrec takes arguments N, a string, M, a module record, and N2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name, and a binding must not already exist in this environment record for n2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called assert. envrec does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in envrec for n that references m and n2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9. 1. 2. 1 get identifier reference. env name strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called. If env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env name strict empty. Else 150. ECMA International 2024. Note: module environment records always provide this binding. AB let outer be env. Return get identifier reference outer name strict. 9. 1. 2. To new declarative environment. The abstract operation new declarative environment takes argument e, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to e. Return env, 1, 2, 3 new object environment o, w, e. The abstract operation new object environment takes arguments o, an object, w, a boolean, and e, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to o, set env to w, set env to e. Return env, 1, 2, 4 new function environment, f. New target. The abstract operation new function environment takes arguments f, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to f. If f is lexical, set env to lexical. Else, set env to uninitialized. Set env to new target. Set env to f. Return env, 1, 2, 5 new global environment, g. This value, the abstract operation new global environment takes arguments g, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let objrec the new object environment, g, false, null. Let dclrec the new declarative environment, null. Let env be a new global environment record. Set env to objrec. Set env to this value. Set env to dclrec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment, e. The abstract operation new module environment takes argument e, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to e. Return env. ECMA International 2024 151 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon a lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private private environment record has the fields defined in Table 23. Table 23. Private environment record fields, field name, value type, meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names. A list of private names. The private names declared by this class. 9. 2. 1. Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy NV. The abstract operation new private environment takes argument outer privy NV, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy NV. Names, 2. 1. 2. Resolve private identifier. Privy NV. Identifier. The abstract operation resolve private identifier takes arguments privy NV, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy NV. For each private name Pn of names, do A if Pn is identifier. Then, I return Pn. Let outer privy NV be privy NV. Assert. Outer privy NV is not null. Return resolve private identifier. Outer privy NV. Identifier. Point 3 realms. Before it is evaluated, all ECMA script code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24, realm record fields, field name, agent signifier, intrinsics, global object, global ENV, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal, parse node, and V, an array, F, the agent that owns this realm, the global object for this realm, the G, global environment for this realm, meaning, the intrinsic values used by code associated with this realm, a list of records, with fields are, a string, and a module record. Note 1. Once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2. As mentioned in host load imported module 16.2.1.8. Note 1. In realm records is only used when running an import expression in a context where there is no active script or module field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9, 3, 1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec, set realm rec to agent signifier, set realm rec to undefined, set realm rec to undefined, set realm rec to a new empty list, return realm rec, ECMA International 2024 153, 9, 3, 2 create intrinsics. Realm rec, the abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in Table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm reg, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform add restrict, add function properties, realm reg, return unused, 3.3 set realm global object, realm reg, global obj, this value. The abstract operation set realm global object takes arguments realm reg, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called if global obj is undefined. Then, A. Let intrinsics be realm reg. B. Set global obj to ordinary object create, intrinsics, assert. Global obj is an object if this value is undefined. Set this value to global obj, set realm rec to global obj, let new global env be new global environment, global obj, this value, set realm rec to new global env, return unused, 3.4 set default global bindings, realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called let global be realm rec. For each property of the global object specified in clause 19, do A. Let name be the string value of the property name. B. Let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. C. Perform. Define property or throw, global, name, desc, return global. Point 4 Execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component, purpose, code evaluation state, any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function, if this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm, the realm record from which associated code accesses ECMA script resources, script or module, the module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in, first-out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component purpose. Lexical environment identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment identifies the environment record that holds bindings created by variable statements within this execution context. Private environment identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code, let strict be true, else let strict be false. Return, get identifier reference, env, name, strict, 4.3 Get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment too. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding, 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion contain on an ECMA script language a value or a throw completion. It determines the binding of the keyword thus using the lexical environment of the running execution context. It performs the following steps when called: let envrec beget this environment, return envrec get this binding, 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called: let envrec beget this environment, assert envrec has a field, return envrec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called: 2.5 let current realm be the current realm record. Return current realm, jobs and host operations to enquid jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enquid generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enquid promise job and host enquid timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm that owns the realm.
The GPU.
Is provided instead for the realm, then the job does not evaluate ECMA.
Right here,
Their implementation.
in this demo, whatever, he creates this on the stack every single time draws a frame.
There is no running code.
So it's like a waste in general to like waste
Implementation must
the time on the CPU assigning these properties. If it's like submit info,
find cleanup steps.
if they don't change, it's the same thing every time. So save it once and then copy paste it. Well, it doesn't even have to copy paste it, just pass it in.
Evaluation of a
It's also a waste on the GPU side. So this should be moved outside of the function, assigned it once, passed in every time, as long as it doesn't change. Except you'd have to make 2 of them, because there is 2 frames or whatever, swap chain things. So make it for one and the other, pass in every frame.
and Node.js.
But this probably changes now and then. That's probably why it's set up to not make a copy that gets passed in every time.
Priority at any particular
So maybe not.
script or module.
But the GPU
A module
makes a copy of all this shit that you pass in.
will if all of the following conditions are true. Get active script or module. Is script or module. If script,
To assign all his properties, pass it in.
let ec be the topmost execution context on the execute
This should all be done GPU side.
is script or module.
The GPU should have some machine instructions.
Time
You make a loop, you set data, so it doesn't have to make copies.
conditions are true.
The GPU makes no fucking sense.
Empty. The realm component of the topmost
It's fucking tied to the CPU.
context.
The CPU does half the fucking work,
Particular kinds of jobs.
if not more, and the GPU wastes time making copies.
Callback records. A job callback record is a record value used to store a function object and a host defined
And then the GPU has to like set aside a certain amount of memory,
by the host may
so it's able to make a copy of what you pass to it.
propagate the state.
That has nothing to do with graphics processing.
Capture and call function. function objects direct.
Or it does, I guess, technically.
Use host make
So maybe if you have like a 20 gigabyte video card,
back records have the field
you can pass more structures and shit because the GPU doesn't fucking process.
for 5.2 host
Well, it does. This stuff is just so dumb and annoying.
takes argument callback. A function
The terminology makes no sense.
callback record
I can't just like assume anything based off what it's called.
to the following requirement.
It's so frustrating.
A job callback record whose field is callback. Note to hosting environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial
The command buffer is set up once, I think, initially, but not really.
quote, when a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the
Because it calls this every single fucking frame.
https://html.spec.whatwg.org, for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when
So here's is this a stack? Is it making a stack?
used by hosts. 158, ECMA International 2024.
Internally,
Of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, V, an ECMA script language value, and
so the command buffer is tied to the current frame.
values, and returns either a normal completion containing an
It's an opaque handle.
completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback, V.
Peek into command buffer.
Default implementation of host call job callback performs the following steps when called. Assert is callable. Job callback is true. Return call. Job callback back.
Let's type vk command buffer.
CMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job. Job realm
And vk command buffer.
operation
Is that a handle, a struct?
a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by
Big pointer.
future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority.
Point to internal driver object or integer handle.
Generic job must conform to the
Never dereference it or access its contents.
5.
All operations happen through Vulkan API calls.
Find abstract operation host enqueue promise job take.
The terminology is so annoying to say record commands into which, for fuck's sake.
It schedules job to be
Think of it as reference to GPU side command list. Yeah, that makes a lot of sense.
related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to
Is it a stack?
as well as the following. If realm is not null, each time job is in
Internally,
perform implementation define steps such that execution is prepared to evaluate ECM
does the GPU execute
invocation. Let script form of
each sequence when requested or when called?
quote. If realm is not null, each time job is invoked, the implementation must perform implementation define steps such that script for module is
Or does the GPU
jobs invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that
place info passed in
it's being eventually scheduled and run. For example,
on a stack
action calls make job callback on then action at the time.
and then execute?
Then, not at the time of scheduling.
everything.
Requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 100.
What's it called? End.
Jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function.
Is that why you reset the command buffer?
Undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm complete.
Because otherwise it'll just keep accumulating.
Proxy.
Does that mean the command buffer doesn't change from last time?
Call. When the
So when I call reset after you're done, after calling end, so it's reset all the time.
script
Like I called before.
Multiple error objects will be created. The WHATWGHTML specification.
In assembly, you usually set the register to 0
HTML.
to prepare for the next time. Why leave the command buffer full of shit instead of just reset it?
And for the entry, https://
You gotta like always remember, does it have to be reset in the first place? Maybe that's why.
accept, 5.6 host enqueue timeout job, realm, milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the
Until VK end writer pass is called.
An implementation of host enqueue timeout job must conform to the requirements in 9.5, 9.6 initialize host defined realm. The abstract operation initialize host defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called: let realm be create realm, let new context be a new execution context, set the function of new context to null, set the realm of new context to realm, set the script or module of new context to null, push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object, created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that the this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global, this value 0. Let global OB.
Because you call reset, then you call begin. Should those be the same thing?
Create any host-defined global object properties on global obj. 2. Return unused. 0.7 agents. An agent comprise is a set of ECMA script execution contexts, an execution context stack, a running
And does reset command buffer need to be called
thread, except for the executing thread
initially?
of an agent belong exclusively to that agent. An agent's executing thread
Before
execution contexts independently of other agents, except that an executing thread may be used as the execute.
begin command buffer is called.
Provided none of the agents sharing the thread have an agent record whose field is true. Note 1: some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60. Copyright.
And if reset is not called,
While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the
after VK end buffer,
level execution objects held within the agent, the running execution context, the execution context stack.
will calling begin.
Agent signifier is a globally unique opaque value used to identify an agent. Table 29, agent record field.
Will calling VK begin.
A boolean, the default value compute
Command buffer
parameter when it is needed by the algorithms get value from buffer and set value.
cause it to append
Implementation defined and should
to whatever
sufficient for the implementation. What
was in the buffer.
change can a boolean.
prior
Signifier, an agent
or
signifier
after that last
is lock in true if atomic operations on one
and the command buffer was called.
false otherwise is lock free 2 a boolean true if atomic operations on 2-byte values are lock free. False otherwise is lock free 8 a boolean true if atomic operations on 8-byte values are lock free. False otherwise candidate execution
So it's a last in, first out stack,
kept alive
and it's not GPU instructions,
initial
it's driver stuff.
of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMA script implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic
This is CPU side, this isn't
operation is
GPU side.
lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See read shared memory and write shared memory for details. ECMA International 2024-161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps.
I'm saying,
Be the agent.
so it's CPU side question mark because it said,
7
no, the CPU is just recording it into the command buffers.
an agent.
No GPU work happens, so CPU call returns immediately.
It
It says CPU only waits if you use fences or exploit synchronization.
record of the surround
Oh, that's what fences are for.
agent clusters. No
That's when it sends, does a data transfer.
given agent.
It's not a fucking fence.
For example,
Oh, it's fucking stupid. So they tried to like remove
still allowing
the technicality of what's actually going on by using clever naming conventions. Stupid fuckers.
free agent below
Unless it's not true. Maybe it's not true. Oh, that's Chatbot. Somehow Chatbot will know, because Chatbot's supposed to be smart.
active agent records all agents within a cluster
So his fences
for the field in their respect.
code word for memory transfer to GPU.
Use for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress. An agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note
Because I'm saying, how the fuck does the CPU not have to wait for the GPU to respond after it sent the data?
for shared
Because the CPU can't just send data. It can't just send.
communicate by message passing that cannot share memory. They are never in the same agent cluster. Note to the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3. If different
Oh my god, where is it?
cluster have different values of it becomes hard.
The CPU can't do. It can't send set viewport, pass in the descriptor, set command, scissors, pass in whatever to scissor. It can't send. It can't send vertex buffer, whatever to pass in.
Another
It can't just send all this stuff without waiting on reply.
if an HT
Because if it sends this to the GPU, the GPU gets it. It has to wait
of such any
for the GPU to send back that it's done.
document and it
Because it can only take, there's only so many ports. If it even, it's not technically a port.
is pushed into
The CPU has ports to execute things. The CPU is not even a fucking CPU.
then the shared worker will be
Fucking software.
dedicated worker is
But it can't just send things like this without some kind of synchronization. All this has to be CPU side.
It will not be possible
It's not even on the fucking GPU.
that don't belong to the same system.
And we call fucking
An embedding may terminate an agent with
fence or whatever the fuck. That's when it does the transfer.
or
It's not waiting.
cooperated not by programmatic action of its own or of another agent in the
What is reset fences?
cluster, then the embedding must choose one of two strategies. Either terminate all the agents in the cluster
Wait for it, so waiting for transfer.
or the agents in the cluster.
Reset for another transfer.
The remaining member of the cluster will be able to detect
Acquire next image.
termination data containing enough information.
So it's like, wait for more memory.
Each of the following specification values and values transitively reachable from them belong to
Getting the next image from a semaphore.
execution record.
Is that what's actually going on?
Record. Prior to any evaluation of any ECMA script code by any agent
Because you call reset fences after you update the uniform buffer.
candidate execution. The initial action
What the hell does update uniform buffer do?
and variable declaration
Oh, that's all the operations it assigns.
an object
To like rotate the fucking thing.
will scope.
And this is all CPU side.
MA script object value declarative record
And you sign it to the uniform buffers mapped.
contains bindings for all declarations in global code for the associated
Then you call reset. So reset doesn't even reset. It resends
a sync function declaration
the fences.
ration,
Because you pass into it inflate fence,
list of strings
which is tied to what? Oh my god, this is so confusing and annoying as hell.
function declaration, a sync generator declaration, and variable declaration declarations in global code for the associated realm. ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method, purpose, get this binding, return the value of this environment records this binding, has
VKQ submit.
if the argument
Oh, I just don't care.
environment record that was created using a variable declaration, function declaration, generator declaration, a sync function declaration, or a sync generator declaration, has lexical declaration, N, determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property, N, determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare
It says let's go carefully, very direct.
determines if
Where command buffers live. A command buffer is CPU side memory. Oh my god.
the global
When you call a command, you are not sending anything to the GPU yet.
global
You're just writing instructions to the CPU side buffer.
argument
But it told me
D, used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property
it said, no, it's not a stack. In the CPU sense,
UN is
it said, conceptually, you can think of it as
may be deleted.
a list of GPU instructions,
Binding followed by
not a last in first out stack. And that's exactly what the fuck it is. And even worse, it's not even on the GPU. It's a fucking CPU list.
global environment.
It's a fucking CPU last in first out stack.
The corresponding global object.
The GPU, this stuff is so stupid.
The string
Like literally.
V is the initial
Like literally.
Boolean argument
Stupid. Literally.
be deleted.
I need to read this stupid documentation.
Global binding
This stuff is so fucking dumb.
allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 4, 1 has binding, N, the has binding concrete method of a global environment record envrec takes argument N, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called let DCLREC be envrec. If DCLREC has binding, N is true, return true. Let OBJREC be envrec. Return OBJREC has binding, n, 1, 1, 4, 2 create mutable binding, n, d, the create mutable binding concrete method of a global environment record env rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the num n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If d is true, the new binding is marked as being subject to deletion. It performs the following steps when called let dclrec be env rec. If dclrec has binding, n is true, throw a type error exception, return. dclrec create mutable binding, n, d, 1, 1, 4, 3 create a mutable binding, n, s, the create immutable binding concrete method of a global environment record env rec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the num n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called let dclrec be env rec. If dclrec has binding, n is true, throw a type error exception, return. dclrec create a mutable binding, n, s, for initialize binding, n, v. The initialize binding concrete method of a global environment record env rec takes arguments n, a string, and v, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called let dclrec be env rec. If dclrec has binding, n is true, then a return. dclrec initialize binding, n, v, assert. If the binding exists, it must be in the object environment record. Let objrec be env rec. Return. Objrec initialize binding, n, v, 1, 1, 4, 5 set mutable binding, n, v, s. The set mutable binding concrete method of a global environment record env rec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let dclrec be env rec. If dclrec has binding, n is true, then a return. dclrec set mutable binding, n, v, s. Let objrec be env rec. Return. Objrec set mutable binding, n, v, s, 1, 1, 4, 6 get binding value, n, s. The get binding value concrete method of a global environment record env rec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding is an uninitialized binding. Throw a reference error exception. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let dclrec be env rec. If dclrec has binding, n is true, then a return. dclrec get binding value, n, s. ECMA International 2024 145 3. Let objrec be env rec. Return. Objrec get binding value, n, s, 1, 1, 4, 7 delete binding, N. The delete binding concrete method of a global environment record env-rec takes argument N, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called let dcl-rec be env-rec. If dcl-rec has binding N is true, then a return dcl-rec delete binding N let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be has own property global object N. If existing prop is true, then a let status be obj-rec delete binding N. B. If status is true and env-rec contains N, then I remove N from env-rec. C return status return true, 1, 1, 4. 8 has this binding. The has this binding concrete method of a global environment record env-rec takes no arguments and returns true. It performs the following steps when called return true, 1, 1, 4. 9 has super binding. The has super binding concrete method of a global environment record env-rec takes no arguments and returns false. It performs the following steps when called return false, 1, 1, 4. 1, 0 with base object. The with base object concrete method of a global environment record env-rec takes no arguments and returns undefined. It performs the following steps when called return undefined 9, 1, 4, 1, 1 get this binding. The get this binding concrete method of a global environment record env-rec takes no arguments and returns a normal completion containing an object. It performs the following steps when called return env-rec. 146. ECMA International 2024. Note: global environment records always provide this binding. Note: global environment records do not provide a super binding. 9, 1, 4. 1, 2 has var declaration N. The has var declaration concrete method of a global environment record env-rec takes argument N, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called let var declared names be env-rec. If var declared names contains N, return true, return false, 1, 1, 4. 1, 3 has lexical declaration N. The has lexical declaration concrete method of a global environment record env-rec takes argument N, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration.
Am I wrong about the fence? That's when they send memory.
Steps when
I hope I'm wrong.
env-rec return dcl-rec.
GPU does not execute anything only when you submit.
1, 4 has
Does the GPU see the commands?
The has restricted global property concrete method of a global environment record
The commands are executed in order, but Vulkan doesn't require in and render paths to start.
containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding.
Execution is controlled by a queue submission.
Let obj-rec be
The CPU wait after each command call.
let exist
No GPU work.
if existing
CPU only waits if you use fences. Or explicitly
return false, return true, the 1st of April 2015 can declare global var N. The can declare global var concrete method of a global environment record env-rec takes argument N, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called let obj-rec be env-rec. Let global object be obj-rec. Let has property be has own property global object N. If has property is true, return true. Return is extensible global object. Note: properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global
So I think you can record to an I don't care, whatever.
of the global object. The global property undefined is an example of such a property. ECMA International 2024 147 9 1 1 4 1 6 can declare global function
I'm gonna go back to the documentation.
in concrete method of a global.
Skip through it.
vrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object n if existing prop is undefined. Return is extensible. Global object if existing prop is true. Return true if is data descriptor. Existing prop is true and existing prop has attribute values. True, enumerable. True. Return true. Return false. 1 1 4 1 7 create global var binding n d. The create global var binding concrete method of a global environment records
So offense is not a memory transfer.
and e, a boolean, and returns either an
You signal it when GP work completes.
completion. It creates and initializes a mutable binding in the associated object environment
So you signal it.
in the associated list,
Why would I signal that GP work completed?
assumed to be initialized.
The GPU does the GPU work, so how the fuck do I know that the GPU is done?
NVRec. Let global object be objrec. Let has property b. Has own property, global object, n. Let extends
I'm just gonna go through the documentation then.
global object. If has property is false and extensible is true, then a perform. Objrec create mutable binding, n d b perform. Objrec initialize binding, n undefined. If envrec does not contain n, then a append enter envrec 7. Return unused, 1 1 4 1 8 create global function binding, n v d. The create global function binding can crep e method of a global environment record envrec takes arguments n
So you want to spell out when data actually crosses PCIe.
and e.
Yeah, no, I don't care.
Turns either in
There's a bunch of extra copies being made.
store a throw completion. It creates
The terminology for this API is trash.
associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8 replaced. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object n. If existing prop is undefined or existing prop is true, then a. Let desc be the property descriptor.
So I need to make another quad,
D else
I think.
be the property descriptor. V perform. Define property or throw global object n desc.
That'd be best.
Set global object.
Draw them to the same frame, wherever the fuck it is, swap chain.
Vrec does not contain n.
Make sure you got that down because I need 2 or 3 layers anyways.
48.
Then I'm gonna like convert over the rest of the Vulkan API tutorial.
Design properties of the global object. If possible,
This API is garbage.
property is reconfigured to have a standard set of attribute values. Step 7 is equivalent.
So I want to figure out a couple more things. Just read the documentation.
Object is a proxy
Then get back to like,
trap call.
I gotta group all these related things into a qua, whatever the fuck I called it.
Module
So I can make duplicates
imperative in
and render them to the same frame.
the outer scope of an ECMA script module. In a
This stuff is overly complicated.
environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms: 1 1 5 1 get binding value N, S. The getBindingValue concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language a value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called assert. S is true, assert. envrec has a binding for n. If the binding for n is an indirect binding, then A let m and n2 be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value. N2 true. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note S will always be true because the module is always strict mode code 9, 1, 1, 5. To delete binding n. The delete binding concrete method of a module environment record is never used within this specification. Method purpose create import binding n, m, n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and n2 is a binding that exists in m's module environment record. Get this binding, return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note module environment records are only used within strict code, and an early error rule prevents the delete operator, in strict code, from being applied to a reference record that would resolve to a module environment record binding. C13, 5, 1, 1, 1, 1, 5, 3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called return true, 1, 1, 5, 4 get this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called return undefined, 1, 1, 5, 5 create import binding n, m, n2. The create import binding concrete method of a module environment record envrec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called assert. envrec does not already have a binding for n, assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in envrec for n that references m and n2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9, 1, 2, 1 get identifier reference, env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called if env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env, name, strict, empty. Else, 150, ECMA International 2024. Note, module environment records always provide this binding, AB, let outer be env, return, get identifier reference, outer, name, strict. 9, 1, 2, to new declarative environment, E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to e. Return env, 1, 2, 3 new object environment o, w, e. The abstract operation new object environment takes arguments o, an object, w, a boolean, and e, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to o. Set env to w. Set env to e. Return env, 1, 2, 4 new function environment f. New target. The abstract operation new function environment takes arguments f, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to f. If f is lexical, set env to lexical, else. Set env to uninitialized. Set env to new target. Set env to f. Return env, 1, 2, 5 new global environment g. This value. The abstract operation new global environment takes arguments g, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let obj rect the new object environment g, false, null. Let dcl rect the new declarative environment. Commands that create Vulkan objects serve the form vk create and take vk create info structures with the parameters needed to create the object. These Vulkan objects are destroyed with commands of the form vk destroy. The last in parameter to each command that creates or destroys a Vulkan object is pallocator. The pallocator parameter can be a non-null value, in which case allocations for the given object are delegated to an application provided callback. Refer to the memory allocation chapter for further details. Commands that allocate Vulkan objects owned by pool objects serve the form vk allocate and take vk allocate info structures. These Vulkan objects are freed with commands of the form vk free. These objects do not take allocators. If host memory is needed, they will use the allocator that was specified when their parent pool was created. Commands are recorded into RICM and buffered by calling API commands of the form vkcmd. Each such command may have different restrictions on where it can be used, in a primary and or secondary command buffer, inside and or outside a render pass, and in one or more of the supported queue types. These restrictions are documented together with the definition of each such command. The duration of a Vulkan command refers to the interval between calling the command and its return to the caller.
Of course the Mac has some memory leak. I gotta restart the computer for text-to-speech to work. Oh, this is so annoying. It's PDF everywhere. Shit. You click next page, it goes like 4 or 5 pages. God. It won't even play music. Something is wrong with the Windows sound driver. I mean Apple sound driver. Waiting for the computer to turn on. Is YouTube Music free? I forgot to update the payment method, but like, it's all still available. Or is that just for like YouTube Premium? I don't know, it still works. So I guess I won't pay yet until it stops working. It's been like a week. Wait, it's free? YouTube Music without a subscription is useless. YouTube Premium comes with YouTube Music. Wow, I didn't pay yet. They said I have to like update the payment method. And it still works, so I guess it just works then. Back to documentation. Hooray.
Three, 5, 1. Lifetime of retrieved results. Information is retrieved from the implementation with commands of the form vkget and vkenumerate. Unless otherwise specified for an individual command, the results are invariant. That is, they will remain unchanged when retrieved again by calling the same command with the same parameters, so long as those parameters themselves all remain valid. 3.6. Threading behavior. Vulkan is intended to provide scalable performance when used on multiple host threads. All commands support being called concurrently from multiple threads, but certain parameters, or components of parameters, are defined to be externally synchronized. This means that the caller must guarantee that no more than one thread is using such a parameter at a given time. More precisely, Vulkan commands use simple stores to update the state of Vulkan objects. The implementation may not synchronize accesses to memory parameters or object parameters declared as externally synchronized with other accesses. If two commands access the same object or memory and at least one of the commands declares the object to be externally synchronized, then the caller must guarantee not only that the commands do not execute simultaneously, but also that the two commands are separated by an appropriate memory barrier if needed. Similarly, if a Vulkan command accesses a non-const memory parameter and the application also accesses that memory, or if the application writes to that memory and the command accesses it as a const memory parameter, the application must ensure the accesses are properly synchronized with a memory barrier if needed. Memory barriers are particularly relevant for hosts based on the ARM CPU architecture, which is more weakly ordered than many developers are accustomed to from x86/x64 programming. Fortunately, most higher-level synchronization primitives, like the thread library, perform memory barriers as a part of mutual exclusion, so mutexing Vulkan objects via these primitives will have the desired effect. Any object parameters that are not labeled as externally synchronized are either not mutated by the command or are internally synchronized. Additionally, certain objects related to a command's parameters, for example command pools and descriptor pools, may be affected by a command, and must also be externally synchronized. These implicit parameters are documented as described below. Parameters of commands that are externally synchronized are listed below.
Oh my god, it's a lot of commands. Holy fuck. This API is stupid. Yeah, I just gotta like memorize all this shit. Okay. Oh, so that's like, holy crap.
The fence parameter in VKQ submit, the queue parameter in VKQA title, the memory parameter in VK free memory, the memory parameter in VK map memory, the memory parameter in VK unmap memory, the buffer parameter in VK bind buffer memory, the image parameter in VK bind image memory, the queue parameter in VKQ bind sparse, the fence parameter in VKQ bind sparse, the fence parameter in VK destroy fence, the semaphore parameter in VK destroy semaphore, the event parameter in VK destroy event, the event parameter in VK set event, the event parameter in VK reset event, the query pool parameter in VK destroy query pool, the buffer parameter in VK destroying buffer, the buffer view parameter in VK destroying buffer view, the image parameter in VK destroy image, the image view parameter in VK destroy imaged view, the shader module parameter in VK destroy shader module, the pipeline cache parameter in VK destroy pipeline cache, the DST cache parameter in VK merge pipeline caches, conditionally 1, the pipeline cache parameter in VK create graphics pipelines, conditional.
This is a fucking mess. Instead of like organizing these things, they're all just command calls. I don't even know. This is ridiculous. How? I don't know. Is there not a better way for any of this to be done? Just let people access the fucking GPU. I guess it's a lot more work. This is a lot of work too, so I don't even fucking know. GPU's crap. Everything sucks.
There are also a few instances where a command can take in an application allocated list whose contents are externally synchronized parameters. In these cases, the caller must guarantee that at most one thread is using a given element within the list at a given time. These parameters are listed below. Valid usage for flags. A collection of flags is represented by a bitmask using the type of VK flags, provided by VK version 1.0, type def-in32T VK flags. Bitmasks are passed to many commands and structures to compactly represent options, but VK flags is not used directly in the API. Instead, a VK flags type, which is an alias of VK flags, and whose name matches the corresponding VK flag bits that are valid for that type, is used. Any VK flags member or parameter used in the API as an input must be a valid combination of bit flags. A valid combination is either 0 or the bitwise or of valid bit flags. An individual bit flag is valid for a VK flags type if it would be a valid enumerant when used with the equivalent VK flag bits type, where the bits type is obtained by taking the flag type and replacing the trailing flags with flag bits. For example, a flag value of type VK color component flags must contain only bit flags defined by VK color component flag bits. Any VK flags member or parameter returned from a query command or otherwise output from Vulkan to the application may contain bit flags undefined in its corresponding VK flag bits type. An application cannot rely on the state of these unspecified bits. Only the low order 31 bits, bit positions 0 through 30, are available for use as flag bits. This restriction is due to poorly defined behavior by C compilers given a C-note enumerant value of 0x80 million. In some cases, adding this enumerant value may increase the size of the underlying VK flag bits type, breaking the ABI. A collection of 64-bit flags is represented by a bitmask using the type of VK flags 64, provided by VK version 1.3, VKKHR synchronization 2, type def-in64T VK flag 64. When the 31 bits available in VK flags are insufficient, the VK flag 64 type can be passed to This restriction is due to poorly defined behavior by C compilers given a C-note enumerant value of 0x80 million. In some cases, adding this enumerant value may increase the size of the underlying VK flag bits type, breaking the ABI.
Do they not know? Do they not know how enums work? Enums are an enumeration, meaning you enumerate. Oh, these people don't know what they're doing. Oh my god, so stupid. I won't even. If that's the issue, then don't use enums. You can't make an enum with that number. It's negative. It's a negative enum. I won't even, whatever. To talk about anything being poorly defined or behavior, you complain about the C compiler. Oh, this documentation. Hypocrisy. So hypocritical. This documentation blows. And they complain about C sucking. Everything sucks.
Commands and structures to represent up to 64 options. VK flag 64 is not used directly in the API. Instead, a VK flags 2 type, which is an alias of VK flag 64, and whose name matches the corresponding VK flag bits to that are valid for that type, is used. Any VK flags 2 member or parameter used in the API as an input must be a valid combination of bit flags. A valid combination is either 0 or the bitwise or of valid bit flags. An individual bit flag is valid for a VK flags 2 type if it would be a valid enumerant when used with the equivalent VK flag bits 2 type, where the bits type is obtained by taking the flag type and replacing the trailing flags 2 with flag bits 2. For example, a flag value of type VK access flags 2 KHR must contain only bit flags defined by VK access flag bits to KHR. Any VK flags 2 member or parameter returned from a query command or otherwise output from Vulkan to the application may contain bit flags undefined in its corresponding VK flag bits 2 type. An application cannot rely on the state of these unspecified bits. Both the VK flag bits 2 type and the individual bits defined for that type are defined as int64T integers in the C API. This is in contrast to the 32-bit types, where the VK flag bits type is defined as a C enum and the individual bits is enumerants belonging to that enum. As a result, there is less compile time type checking possible for the 64-bit types. This is unavoidable since there is no sufficiently portable way to define a 64-bit enum type in C99. Valid usage for structure types. Any parameter that is a structure containing a S-type member must have a value of S-type, which is a valid VK structure type value matching the type of the structure.
Oh my god. Do they not know how C language works? I don't understand. The API is in C language. In C, there is no 64-bit enum. Why are they defining things as enums? Why not just use integers for the 32-bit? Oh my god, the stupidity. They're so fucking stupid. They're restricting the language or whatever the fuck. They're restricting their API to C language. There are so many ways around this. These people are idiots. Fucking idiots. It's like, oh, she doesn't have enums for that type size. There's, you know what? It doesn't matter. That's why this API sucks. Because they don't even know how C language works. They don't even know the workarounds. So of course they can't make a good API. What do they know? Just driver stuff? Do they know assembly? Who wrote this stuff? How could you write? Oh, whatever. And then it's like, oh, because of this, that's the excuse. Oh, excuses.
The type of the structure.
Is this like a bit field? This is not accumulated. They're like setting bits to indicate the structure. Oh my god, is half the documentation structure types? Oh my god, structures are equal to other structures.
Point 13. API name aliases. A small number of APIs did not follow the naming conventions when initially defined. For consistency, when we discover an API name that violates the naming conventions, we rename it in the specification, XML, and header files. For backwards compatibility, the original, incorrect, name is retained as a typo alias. The alias is deprecated and should not be used, but will be retained indefinitely. VK stencil front and back is an example of a typo alias. It was initially defined as part of VK stencil face flag, but once the naming inconsistency was noticed, it was renamed to VK stencil face front and back, and the old name was alias to the correct name.
Oh my god. This API blows. It blows. Oh my god, it blows. Freaking blows. It's an absolute turd. went back to like finding all the different objects, because they call them objects, that make up the quad. So I can isolate this quad, make another one, and paint them to the same command buffer. Do multiple quads go to the same command buffer? Or do they go to the same pipeline? I'm not sure yet. I'm gonna figure that out, I guess. I'm gonna like regroup these things that make up this thing so I can make two things. Oh, this makes no fucking sense. This API is crap.
Declaration, async generator declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings. Var names, a list of strings. The string names bound by function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration declarations in global code for the associated realm. ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method, purpose, get this binding, return the value of this environment records this binding, has a declaration, n, determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generator declaration, async function declaration, or async generator declaration, has lexical declaration, n, determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property, n, determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare global var, n, determines if a corresponding create global var binding call would succeed if called for the same argument, n, can declare global function, n, determines if a corresponding create global function binding call would succeed if called for the same argument, n, create global var binding, n, d, used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N, V, D, create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 4, 1 has binding. N, the has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n is true, return true. Let objrec be envrec. Return objrec has binding, n, 1, 4, 2 create mutable binding, n, D, the create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and E, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the num n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If D is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n is true, throw a type error exception. Return DCLREC create mutable binding, n, D, 1, 4, 3 create a mutable binding, n, S, the create immutable binding concrete method of a global environment record envrec takes arguments n, a string, and S, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the num n that is uninitialized. A binding must not already exist in this environment record for NFS is true. The new binding is marked as a strict binding. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n is true, throw a type error exception. Return DCLREC create a mutable binding, n, S, for initialize binding, n, V. The initialize binding concrete method of a global environment record envrec takes arguments n, a string, and V, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n is true, then a return DCLREC initialize binding, n, v. Assert. If the binding exists, it must be in the object environment record. Let objrec be envrec. Return objrec initialize binding, n, v, 1, 4, 5 set mutable binding, n, v, s. The set mutable binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n is true, then a return DCL rec set mutable binding NVS let obj rec benv rec return obj rec set mutable binding NVS, 1 1 4 6 get binding value NS. The get binding value concrete method of a global environment record env rec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language a value or a throw completion. It returns the value of its bound identifier whose name is only if the binding is an uninitialized binding throw a reference error exception. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let DCL rec benv rec. If DCL rec has binding n is true, then a return DCL rec get binding value n s. ECMA International 2024 145 3. Let obj rec benv rec return obj rec get binding value n s, 1 1 4 7 delete binding n. The delete binding concrete method of a global environment record env rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called let DCL rec benv rec. If DCL rec has binding n is true, then a return DCL rec delete binding n. Let obj rec benv rec. Let global object be obj rec. Let existing prop be has own property global object n. If existing prop is true, then a let status be obj rec delete binding n. B. If status is true and env rec contains n, then I remove n from env rec. C return status return true, 1 1 4 8 has this binding. The has this binding concrete method of a global environment record env rec takes no arguments and returns true. It performs the following steps when called return true, 1 1 4 9 has super binding. The has super binding concrete method of a global environment record env rec takes no arguments and returns false. It performs the following steps when called return false, 1 1 4 1 0 with base object. The with base object concrete method of a global environment record env rec takes no arguments and returns undefined. It performs the following steps when called return undefined 9 1 1 4 1 1 get this binding. The get this binding concrete method of a global environment record env rec takes no arguments and returns a normal completion containing an object. It performs the following steps when called return env rec. 146 ECMA International 2024. Note: global environment records always provide this binding. Note: global environment records do not provide a super binding. 9 1 1 4 1 2 has var declaration n. The has var declaration concrete method of a global environment record env rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called let var declared names be env rec. If var declared names contains n, return true, return false, 1 1 4 1 3 has lexical declaration n. The has lexical declaration concrete method of a global environment record env rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called let DCL rec benv rec. Return DCL rec has binding n, 1 1 4 1 4 has restricted global property n. The has restricted global property concrete method of a global environment record env rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called: let objrec be envrec, let global object be objrec, let existing prop be global object, n. If existing prop is undefined, return false. If existing prop is true, return false. Return true, comma. The 1st of April 2015 can declare global var n. The can declare global var concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument, and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called: let objrec be envrec, let global object be objrec, let has property b, has own property, global object, n. If has property is true, return true. Return is extensible, global object. Note: properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147 9 1 1 4 1 6 can declare global function n. The can declare global function concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called: let objrec be envrec, let global object be objrec, let existing prop be global object, n. If existing prop is undefined, return is extensible, global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values, true, enumerable, true, return true. Return false, comma 1 1 4 1 7 create global var binding n. D. The create global var binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called: let objrec be envrec, let global object be objrec, let has property b, has own property, global object, n. Let extensible b is extensible, global object. If has property is false and extensible is true, then a perform objrec create mutable binding n. D. B perform objrec initialize binding n. Undefined. If envrec does not contain n, then a append enter envrec 7. Return unused, comma 1 1 4 1 8 create global function binding n. V. D. The create global function binding can create e method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2 3 4 7 8 replaced. It performs the following steps when called: let objrec be envrec, let global object be objrec, let existing prop be global object, n. If existing prop is undefined or existing prop is true, then a. let desc be the property descriptor, v. true, true, d. else a. let desc be the property descriptor, v. perform define property or throw, global object, n. desc perform set global object n. v. false. If envrec does not contain n, then a append enter envrec. Return unused 48. ECMA International 2024. Note: global function declarations are always represented as own properties of the global object. If possible, an existing owned property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy, will produce the same sequence of proxy trap calls. 1. 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding, and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms. 1 get binding value, n, s. The get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called assert. S is true, assert. envrec has a binding for n. If the binding for n is an indirect binding, then A let m and n2 be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value. N2 true. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note S will always be true because the module is always strict mode. Code 9, 5. To delete binding, n. The delete binding concrete method of a module environment record is never used within this specification. Method purpose create import binding, n, m, n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and n2 is a binding that exists in m's module environment record. Get this binding, return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note module environment records are only used within strict code, and an early error rule prevents the delete operator, in strict code, from being applied to a reference record that would resolve to a module environment record binding. C13. 5. 1, 5. 3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called return true, 1, 5. 4 get this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called return undefined, 1, 5. Create import binding, n, m, n2. The create import binding concrete method of a module environment record envrec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called assert. envrec does not already have a binding for n. Assert. When m is instantiated, It will have a direct binding for N2. Create an immutable indirect binding in env for N that references M and N2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9. 1. 2. 1 get identifier reference. env name strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called. If env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env, name, strict, empty. Else. 150, ECMA International 2024. Note, module environment records always provide this binding. AB, let outer be env. Return, get identifier reference, outer, name, strict. 9. 1. 2. To new declarative environment, E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment, O, W, E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O, set env to W, set env to E. Return env, 1, 2, 4 new function environment, F. New target. The abstract operation new function environment takes arguments F, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical. Else, set env to uninitialized. Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment, G. This value, the abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let obj be new object environment, G, false, null. Let DCL be new declarative environment, null. Let env be a new global environment record. Set env to obj set env to this value, set env to DCL set env to a new empty list, set env to null. Return env, 1, 2, 6 new module environment, E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env. ECMA International 2024 151 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value type, meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names. The private names declared by this class. 9. 2. 1 private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy NV. The abstract operation new private environment takes argument outer privy NV, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy NV. Names, 2. 1. 2 resolve private identifier. Privy NV. Identifier. The abstract operation resolve private identifier takes arguments privy NV, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy NV. For each private name Pn of names, do A if Pn is identifier. Then, I return Pn. Let outer privy NV be privy NV. Assert. Outer privy NV is not null. Return resolve private identifier. Outer privy NV. Identifier. Point 3 realms. Before it is evaluated, all ECMA script code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24:52, copyright sign, ECMA International 2024, Table 24. Realm record fields, field name, agent signifier, intrinsics, global object, global ENV, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and V, an array. F, the agent that owns this realm, the global object for this realm, the G, global environment for this realm, meaning, the intrinsic values used by code associated with this realm, a list of records, with fields are, a string, and, a module record. Note 1. Once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2 as mentioned in host load imported module 16.2.1.8. Note 1. In realm records is only used when running an import expression in a context where there is no active script or module. Field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9.3.1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9.3. 2. Create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in Table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function steps. Length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. and prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform add restrict. Ed function properties. Realm rec, return unused, 3.3 set realm global object, realm rec, global OBJ, this value, the abstract operation set realm global object takes arguments realm rec, a realm record, global OBJ, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called if global OBJ is undefined. Then, A. Let intrinsics be realm rec, B. Set global OBJ to ordinary object create, intrinsics, assert. Global OBJ is an object, if this value is undefined. Set this value to global OBJ, set realm rec to global OBJ, let new global env be new global environment, global OBJ, this value, set realm rec to new global env, return unused, 3.4 set default global bindings. Realm rec, the abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called let global be realm rec, for each property of the global object specified in clause 19. Do A. Let name be the string value of the property name, B. Let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4 the value of the attribute is the corresponding intrinsic object from realm rec, C. Perform. Define property or throw, global, name, desc, return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component, purpose, code evaluation state, any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function, if this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm, the realm record from which associated code accesses ECMA script resources, script or module, the module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in, first-out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component, purpose, lexical environment, identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment, identifies the environment record that holds bindings created by variable statements within this execution context. Private environment, identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024-155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code, let strict be true, else let strict be false. Return, get identifier reference, env, name, strict, 4.3 Get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment too. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding. 4.4 Resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion contain on an ECMA script language a value or a throw completion. It determines the binding of the keyword thus using the lexical environment of the running execution context. It performs the following steps when called. Let env-rec beget this environment. Return env-rec get this binding. 4.5 Get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let envrec beget this environment. Assert envrec has a field. Return envrec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024-157. Note 1 host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority at any particular time. Script or module. A script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module. Is script or module. If script or module is a script record or module record. Let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMA script code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enqueue by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields, 5.2 host make job callback. Callback. The host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note 2 host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG specification, https://html.spec.whatwg.org, for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158, ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback, empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback, v. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, v. an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback, v. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert, is callable. Job callback, is true. Return, call. Job callback, v. Arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job. Job. Realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5, 5 host enqueue promise job. Job. Realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script or module beget active script or module at the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, No user ECMA script code will be evaluated and no new ECMA script objects, for example error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses Realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org entry. Concept, 5.6 host enqueue timeout job, realm, milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enqueue timeout job must conform to the requirements in 9.5, 9.6 initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called: let realm be create realm, let new context be a new execution context, set the function of new context to null, set the realm of new context to realm, set the script or module of new context to null, push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object, created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global, this value 0. Let global obj be. Set default global bindings, realm 1. Create any host-defined global object properties on global obj 2. Return unused. 7 agents. An agent comprise is a set of ECMA script execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60. Copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent record S fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithms get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block, a boolean, determines whether the agent can block or not. Signifier, an agent signifier, uniquely identifies the agent within its agent cluster. Is lock-free 1, a boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2, a boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8, a boolean, true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list. representing the list of objects and/or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMA script implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See read shared memory and write shared memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a Boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR. Agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. 4. Example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note to the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3. If different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign. ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any Windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wait collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination. with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waiter list record. Prior to any evaluation of any ECMA script code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial action declaration, a sync-generated declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generated declaration, a sync function declaration, a sync generated declaration, and variable declaration bindings. var names, a list of strings. The string names bound by function declaration, generated declaration, a sync function declaration, a sync generated declaration, and variable declaration declarations in global code for the associated realm. ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method, purpose, get this binding, return the value of this environment records this binding, has a declaration, n, determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generated declaration, a sync function declaration, or a sync generated declaration, has lexical declaration, n, determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property, n, determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare global var, n, determines if a corresponding create global var binding call would succeed if called for the same argument, n, can declare global function, n, determines if a corresponding create global function binding call would succeed if called for the same argument, n, create global var binding, n, d, used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding, n, v, d, create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 1, 4, 1 has binding, n, the has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n, is true, return true. Let objrec be envrec. Return objrec has binding, n, 1, 1, 4, 2 create mutable binding, n, d, the create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and d, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the num n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If d is true, The new binding is marked as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, N is true. Throw a type error exception. Return. DCLREC create mutable binding, N, D, 1, 1, 4. 3 create immutable binding, N, S. The create immutable binding concrete method of a global environment record envrec takes arguments N, a string, and S, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the num n that is uninitialized. A binding must not already exist in this environment record for n if S is true. The new binding is marked as a strict binding. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, N is true. Throw a type error exception. Return. DCLREC create a mutable binding, N, S, for initialize binding, N, V. The initialize binding concrete method of a global environment record envrec takes arguments N, a string, and V, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is N to the value V. An uninitialized binding for N must already exist. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, N is true, then a return. DCLREC initialize binding, N, V. Assert. If the binding exists, it must be in the object environment record. Let objrec be envrec. Return. Objrec initialize binding, N, V, 1, 1, 4, 5 set mutable binding, N, V, S. The set mutable binding concrete method of a global environment record envrec takes arguments N, a string, V, an ECMA script language value, and S, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is N to the value V if the binding is an immutable binding and S is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by S. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, N is true, then a return. DCLREC set mutable binding, N, V, S. Let objrec be envrec. Return. Objrec set mutable binding, N, V, S, 1, 1, 4, 6 get binding value, N, S. The get binding value concrete method of a global environment record envrec takes arguments N, a string, and S, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is N if the binding is an uninitialized binding. Throw a reference error exception. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by S. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, N is true, then a return. DCLREC get binding value, N, S. ECMA International 2024 145. 3. Let objrec be envrec. Return. Objrec get binding value, N, S, 1, 1, 4, 7 delete binding, N. The delete binding concrete method of a global environment record envrec takes argument N, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, N is true, then a return. DCLREC delete binding, N. Let objrec be envrec. Let global object be objrec. Let existing prop be has own property, global object, N. If existing prop is true, then a let status be objrec delete binding, n. B if status is true and envrec contains n, then I remove n from envrec. C return status, return true, 1, 1, 4. 8 has this binding. The has this binding concrete method of a global environment record envrec takes no arguments and returns true. It performs the following steps when called return true, 1, 1, 4. 9 has superbinding. The has superbinding concrete method of a global environment record envrec takes no arguments and returns false. It performs the following steps when called return false, 1, 1, 4, 1, 0 with base object. The with base object concrete method of a global environment record envrec takes no arguments and returns undefined. It performs the following steps when called return undefined. 9, 1, 1, 4, 1, 1 get this binding. The get this binding concrete method of a global environment record envrec takes no arguments and returns a normal completion containing an object. It performs the following steps when called return envrec. 146. ECMA International 2024. Note: Global Environment Records always provide this binding. Note: Global Environment Records do not provide a superbinding. 9, 1, 1, 4, 1, 2 Hasvar Declaration. N. The Hasvar Declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called let var declared names be envrec. If var declared names contains n, return true, return false, 1, 1, 4, 1, 3 has lexical declaration. N. The has lexical declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called let dclrec be envrec. Return. dclrec has binding n, 1, 1, 4, 1, 4 has restricted global property. N. The has restricted global property concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called let objrec be envrec. Let global object be objrec. Let existing prop be global object. N. If existing prop is undefined, return false. If existing prop is true, return false. Return true, the 1st of April 2015 can declare global var. N. The can declare global var concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called let objrec be envrec. Let global object be objrec. Let has property be has own property, global object. N. If has property is true, return true. Return is extensible, global object. Note: properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147, 9, 1, 1, 4, 1, 6 can declare global function. N. The can declare global function concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called let objrec be envrec. Let global object be objrec. Let existing prop be global object. N. If existing prop is undefined, return is extensible, global object. If existing prop is true, return true. If is data descriptor, existing prop, is true and existing prop has attribute values, true, enumerable, true, return false, comma 1, 1, 4, 1, 7 create global var binding, n, d, the create global var binding concrete method of a global environment record env-rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called: let objrec be env-rec, let global object be objrec, let has property b, has own property, global object, n, let extensible be, is extensible, global object, if has property is false and extensible is true, then a perform. Objrec create mutable binding, n, d, b perform. Objrec initialize binding, n, undefined. If env-rec does not contain n, then a append enter env-rec 7. Return unused, comma 1, 1, 4, 1, 8 create global function binding, n, v, d, the create global function binding can crep, e method of a global environment record env-rec takes arguments n, a string, v, an ECMA script language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8 replaced. It performs the following steps when called: let objrec be env-rec, let global object be objrec, let existing prop be global object, n, if existing prop is undefined or existing prop is true, then a let desc be the property descriptor, v, true, true, d, else, a let desc be the property descriptor, v, perform. Define property or throw, global object, n, desc, perform. Set, global object, n, v, false. If env-rec does not contain n, then a append enter env-rec. Return unused, 48, ECMA International 2024. Note: global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls, comma 1, 1, 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms, comma 1, 1, 5, 1 get binding value, n, s, the get binding value concrete method of a module environment record env-rec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called: assert, s is true, assert, env-rec has a binding for n. If the binding for n is an indirect binding, Then, A let m and n2 be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value n2 true. If the binding for n in env rec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in env rec. Note S will always be true because a module is always strict mode code 9, 1, 1, 5. To delete binding n, the delete binding concrete method of a module environment record is never used within this specification. Method purpose create import binding n, m, n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and n2 is a binding that exists in m's module environment record. Get this binding, return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note module environment records are only used within strict code, and an early error rule prevents the delete operator, in strict code, from being applied to a reference record that would resolve to a module environment record binding. C13, 5, 1, 1, 1, 1, 5, 3 has this binding. The has this binding concrete method of a module environment record env rec takes no arguments and returns true. It performs the following steps when called return true, 1, 1, 5, 4 get this binding. The get this binding concrete method of a module environment record env rec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called return undefined, 1, 1, 5, 5 create import binding n, m, n2. The create import binding concrete method of a module environment record env rec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called assert. env rec does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in env rec for n that references m and n2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9, 1, 2, 1 get identifier reference. env name strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called if env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env, name, strict, empty. Else, 150, ECMA International 2024. Note, module environment records always provide this binding. AB, let outer be env, return, get identifier reference, outer, name, strict. 9, 1, 2, to new declarative environment, E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment, O, W, E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called let env be a new object environment record. Set env to O, set env to W, set env to E, return env, 1, 2, 4 new function environment, F. target. The abstract operation new function environment takes arguments f, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to f. If f is lexical, set env to lexical, else set env to uninitialized, set env to new target, set env to f, return env, 1, 2, 5 new global environment, g, this value. The abstract operation new global environment takes arguments g, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let objrec be new object environment, g, false, null. Let dclrec be new declarative environment, null. Let env be a new global environment record. Set env to objrec. Set env to this value. Set env to dclrec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment, e. The abstract operation new module environment takes argument e, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to e. Return env. ECMA International, 2024 151, 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon a lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value type, meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names. The private names declared by this class. 9. 2. 1 Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy NV. The abstract operation new private environment takes argument outer privy NV, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy NV. Names, 2, 1. 2 resolve private identifier. Privy NV. Identifier. The abstract operation resolve private identifier takes arguments privy NV, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy NV. For each private name Pn of names, do A of Pn is identifier. Then, I return Pn. Let outer privy NV be privy NV. Assert. Outer privy NV is not null. Return resolve private identifier. Outer privy NV. Identifier. 3 realms. Before it is evaluated, all ECMA script code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24. Realm record fields, field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and v, an array, f, the agent that owns this realm, the global object for this realm, the G, global environment for this realm, meaning, The intrinsic values used by code associated with this realm. A list of records with fields are a string and a module record. Note 1: once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2: as mentioned in host load imported module 162118. Note 1: in realm records is only used when running an import expression in a context where there is no active script or module. Field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 931 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9 3 2 create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function steps. Length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform add restrict. Add function properties. Realm rec. Return unused, 3.3 set realm global object. Realm rec. Global OBJ. This value. The abstract operation set realm global object takes arguments realm rec, a realm record, global OBJ, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global OBJ is undefined, then A. Let intrinsics be realm rec. B. Set global OBJ to ordinary object create intrinsics. Assert global OBJ is an object. If this value is undefined, set this value to global OBJ. Set realm rec to global OBJ. Let new global env be new global environment. Global OBJ. This value. Set realm rec to new global env. Return unused, 3.4 set default global bindings. Realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec. For each property of the global object specified in clause 19, do A. Let name be the string value of the property name. B. Let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. C. Perform. Define property or throw. Global. Name. Desc. Return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component, purpose, code evaluation state, any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMA script resources, script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in, first-out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component, purpose, lexical environment, identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment, identifies the environment record that holds bindings created by variable statements within this execution context. Private environment, identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module, 4.2 resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. Env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code: let strict be true, else let strict be false. Return get identifier reference env name strict, 4.3 get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment too. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding, 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion contained on an ECMA script language a value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called. Let envrec beget this environment. Return envrec get this binding, 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let envrec beget this environment. Assert envrec has a field. Return envrec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 let current realm be the current realm record. Return current realm. Jobs and host operations to enquire jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enquire generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enquire promise job and host enquire timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024-157. Note 1: host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority at any particular time. Script or module. A script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module. Is script or module. If script or module is a script record or module record. Let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMA script code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enquire by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields, 5.2 host make job callback. Callback. The host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note 2: host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158, ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, V, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert. Is callable. Job callback. Is true. Return. Call. Job callback. Back. V. Arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job. Job. Realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5, 5 host enqueue promise job. Job. Realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script for module be get active script for module at the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script for module is the active script for module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMA script code will be evaluated and no new ECMA script objects, for example error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org entry. Concept, 5.6 host enqueue timeout job. Timeout job. Realm. Milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enqueue timeout job must conform to the requirements in 9.5, 9.6 initialize host defined realm. The abstract operation initialize host defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script for module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object, created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object. Let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global, this value 0. Let global obj be set default global bindings, realm 1. Create any host-defined global object properties on global obj 2. Return unused. 7 agents. An agent comprise is a set of ECMA script execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60. Copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent record S fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithms get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block, a boolean, determines whether the agent can block or not. Signifier, an agent signifier, uniquely identifies the agent within its agent cluster. Is lock-free 1, a boolean, true if atomic operations on 1 byte values are lock-free, false otherwise. Is lock-free 2, a boolean, true if atomic operations on 2 byte values are lock-free, false otherwise. Is lock-free 8, a boolean, true if atomic operations on 8 byte values are lock-free, false otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive, a list of either objects or symbols, initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMA script implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See read shared memory and write shared memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR, agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. 4. Example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1 programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note to the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the 3 agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3: if different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign, ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any Windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend wait collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of 2 strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination. With the termination data containing enough information to identify the agent that was terminated, each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waiter list record. Prior to any evaluation of any ECMA script code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial action declaration, a sync-generated declaration, and variable declaration bindings in global code for the associated realm. Global list value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generated declaration, a sync function declaration, a sync generated declaration, and variable declaration bindings. var names, a list of strings. The string names bound by function declaration, generated declaration, a sync function declaration, a sync generated declaration, and variable declaration declarations in global code for the associated realm. ECMA International 2024, 43. Table 21. Additional methods of global environment records. Method purpose: get this binding, return the value of this environment records this binding, has a declaration, n, determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generated declaration, a sync function declaration, or a sync generated declaration, has lexical declaration, N determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property. N determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare global var. N determines if a corresponding create global var binding call would succeed if called for the same argument. N can declare global function. N determines if a corresponding create global function binding call would succeed if called for the same argument. N create global var binding. N D used to create and initialize to undefine a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N, V, D, create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 1, 4, 1 has binding. N, the has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n is true, return true. Let objrec be envrec. Return objrec has binding n, 1, 1, 4, 2 create mutable binding n, D, the create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the num n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If D is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n is true, throw a type error exception. Return dclrec create mutable binding n, D, 1, 1, 4, 3 create a mutable binding n, S, the create immutable binding concrete method of a global environment record envrec takes arguments n, a string, and S, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the num n that is uninitialized. A binding must not already exist in this environment record for n if S is true. The new binding is marked as a strict binding. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n is true, throw a type error exception. Return dclrec create a mutable binding n, S, for initialize binding n, V. The initialize binding concrete method of a global environment record envrec takes arguments n, a string, and V, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n is true, then a return dclrec initialize binding n, v. Assert. If the binding exists, It must be in the object environment record. Let objrec be envrec. Return objrec initialize binding n v, 1 1 4 5 set mutable binding n v s. The set mutable binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding n is true, then a return dclrec set mutable binding n v s. Let objrec be envrec. Return objrec set mutable binding n v s, 1 1 4 6 get binding value n s. The get binding value concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding is an uninitialized binding. Throw a reference error exception. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding n is true, then a return dclrec get binding value n s. ECMA International 2024 145 3. Let objrec be envrec. Return objrec get binding value n s, 1 1 4 7 delete binding n. The delete binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding n is true, then a return dclrec delete binding n. Let objrec be envrec. Let global object be objrec. Let existing prop be has own property global object n. If existing prop is true, then a let status be objrec delete binding n. B if status is true and envrec contains n, then I remove n from envrec. C return status. Return true, 1 1 4 8 has this binding. The has this binding concrete method of a global environment record envrec takes no arguments and returns true. It performs the following steps when called. Return true, 1 1 4 9 has super binding. The has super binding concrete method of a global environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 4 1 0 with base object. The with base object concrete method of a global environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined 9 1 1 4 1 1 get this binding. The get this binding concrete method of a global environment record envrec takes no arguments and returns a normal completion containing an object. It performs the following steps when called. Return envrec. 146. ECMA International 2024. Note: global environment records always provide this binding. Note: global environment records do not provide a super binding. 9 1 1 4 1 2 hasvar declaration n. The hasvar declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called. Let var declared names be envrec. If var declared names contains n, return true, return false, comma 1, 1, 4, 1 3 has lexical declaration, n, the has lexical declaration concrete method of a global environment record env rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called let dcl-rec be env-rec return. dcl-rec has binding n, 1, 1, 4, 1 4 has restricted global property n, the has restricted global property concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called let objrec be env-rec, let global object be objrec, let existing prop be global object, n, if existing prop is undefined, return false. If existing prop is true, return false. Return true, the 1st of April 2015 can declare global var. N, the can declare global var concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called let objrec be env-rec, let global object be objrec, let has property b, has own property, global object, n, if has property is true, return true. Return is extensible, global object. Note properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147, 9, 1, 1, 4, 1 6 can declare global function, n, the can declare global function concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called let objrec be env-rec, let global object be objrec, let existing prop be global object, n, if existing prop is undefined. Return is extensible, global object. If existing prop is true, return true. If is data descriptor, existing prop, is true and existing prop has attribute values, true, enumerable, true, return true. Return false, 1, 1, 4, 1 7 create global var binding, n, d, the create global var binding concrete method of a global environment record env-rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called let objrec be env-rec, let global object be objrec, let has property b, has own property, global object, n, let extensible b, is extensible, global object. If has property is false and extensible is true, then a perform. Objrec create mutable binding, n, d, b perform. Objrec initialize binding, n, undefined. If env-rec does not contain n, then a append enter env-rec 7. Return unused, 1, 1, 4, 1 8 create global function binding, n, v, d, the create global function binding can crep, e method of a global environment record env-rec takes arguments n, a string, v, an ECMA script language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8 replaced. It performs the following steps when called: let objrec be envrec, let global object be objrec, let existing prop be global object, n if existing prop is undefined or existing prop is true, then a let desc be the property descriptor, v true, true, d else a let desc be the property descriptor, v perform. Define property or throw, global object, n desc, perform. Set global object n v false. If envrec does not contain n, then a append enter envrec. Return unused. 48. ECMA International 2024. Note: global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls. 1. 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms. 1. 1 get binding value, n, s. The get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called: assert s is true, assert envrec has a binding for n. If the binding for n is an indirect binding, then a let m and n2 be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value n2 true. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note s will always be true because a module is always strict mode. Code 9. 1. 5. To delete binding, n. The delete binding concrete method of a module environment record is never used within this specification. Method purpose: create import binding, n, m, n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and n2 is a binding that exists in m's module environment record. Get this binding, return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note: module environment records are only used within strict code, and an early error rule prevents the delete operator, in strict code, from being applied to a reference record that would resolve to a module environment record binding. C13. 5. 1. 1, 5. 3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called: return true, 1. 5. 4 get this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called return undefined, 1, 5, 5 create import binding, n, m, n2. The create import binding concrete method of a module environment record env rec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called assert. Envrec does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in envrec for n that references m and n2 as its target binding and record that the binding is initialized. Return unused, 1. To environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9. 1. 2. 1 get identifier reference. Env name strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called if env is null, then a return the reference record, unresolvable, name, strict. This value, empty, let exists be env has binding, name. If exists is true, then a return the reference record, env, name, strict, empty, else. 150, ECMA International 2024. Note, module environment records always provide this binding, AB, let outer be env, return, get identifier reference, outer, name, strict. 9, 1, 2. To new declarative environment, E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment, O, W, E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called let env be a new object environment record. Set env to O, set env to W, set env to E, return env, 1, 2, 4 new function environment, F. New target. The abstract operation new function environment takes arguments F, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical, else. Set env to uninitialized, set env to new target, set env to F. Return env, 1, 2, 5 new global environment, G. This value, the abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called let objrec be new object environment, G, false, null. Let dclrec be new declarative environment, null. Let env be a new global environment record. Set env to objrec. Set env to this value. Set env to dclrec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment, E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called let env be a new module environment record containing no bindings. Set env to E. Return env. ECMA International 2024 151 9.2 private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value type, meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names. The private names declared by this class. 9. 2. 1 private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy NV. The abstract operation new private environment takes argument outer privy NV, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy NV. Names, 2. 1. 2 resolve private identifier. Privy NV. Identifier. The abstract operation resolve private identifier takes arguments privy NV, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy NV. For each private name Pn of names, do A if Pn is identifier. Then, I return Pn. Let outer privy NV be privy NV. Assert. Outer privy NV is not null. Return resolve private identifier. Outer privy NV. Identifier. Point 3 realms. Before it is evaluated, all ECMA script code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24. 52. Copyright sign, ECMA International 2024. Table 24. Realm record fields, field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and v, an array. F, the agent that owns this realm, the global object for this realm, the G, global environment for this realm, meaning, the intrinsic values used by code associated with this realm, a list of records, with fields are, a string, and, a module record. Note 1. Once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2. As mentioned in host load imported module 16.2.1.8. Note 1. In realm records is only used when running an import expression in a context where there is no active script or module. Field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9. 3. 1. Create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153. 9. 3. 2. Create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record. and returns unused. It performs the following steps when called: set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function steps: length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform add restrict. Ed function properties. Realm rec, return unused, 3.3 set realm global object, realm rec, global obj, this value. The abstract operation set realm global object takes arguments realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called: if global obj is undefined, then A. let intrinsics be realm rec, B. set global obj to ordinary object create intrinsics, assert global obj is an object. If this value is undefined, set this value to global obj, set realm rec to global obj, let new global env be new global environment, global obj, this value, set realm rec to new global env, return unused, 3.4 set default global bindings, realm rec, the abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: let global be realm rec. For each property of the global object specified in clause 19, do A. let name be the string value of the property name, B. let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. C. perform. Define property or throw, global, name, desc, return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component purpose, code evaluation state, any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMA script resources, script or module. The module record or script record from which associated code originates. if there is no originating script or module, as is the case for the original execution context created in initialize host defined realm. The value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last in first out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component purpose. Lexical environment identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment identifies the environment record that holds bindings created by variable statements within this execution context. Private environment identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script for module. The abstract operation get active script for module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script for module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script for module component is not null. If no such execution context exists, return null. Otherwise, return X script for module. 4.2 Resolve binding. Name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code, let strict be true, else let strict be false. Return, get identifier reference, env, name, strict. 4.3 Get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment too. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name. ABCDE. Let let exists be env has this binding. If exists is true, return env. Let outer be env. Assert outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding, 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion contain on an ECMA script language a value or a throw completion. It determines the binding of the keyword thus using the lexical environment of the running execution context. It performs the following steps when called: let envrec beget this environment, return envrec get this binding, 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called: let envrec beget this environment, assert envrec has a field, return envrec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called: 2.5 let current realm be the current realm record. Return current realm, jobs and host operations to enquid jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enquid generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enquid promise job and host enquid timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024-157. Note 1 host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority at any particular time. Script or module. A script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module. Is script or module. If script or module is a script record or module record. Let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMA script T-code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. function objects that are invoked via a job enquire by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields, 5.2 host make job callback. Callback. The host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note to host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158, ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, V, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert. Is callable. Job callback. Is true. Return. Call. Job callback. Callback. V. Arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enquire generic job. Job. Realm. The host-defined abstract operation host enquire generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enquire generic job must conform to the requirements in 9.5, 5 host enquire promise job. Job. Realm. The host-defined abstract operation host enquire promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enquire promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script for module beget active script for module at the time host enquire promise job is invoked. If realm is not null, Each time job is invoked, the implementation must perform implementation-defined steps such that script4module is the active script4module at the time of job's invocation. Jobs must run in the same order as the host enqueue-promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024-159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMA script code will be evaluated and no new ECMA script objects, for example error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org entry, concept, 5.6 host enqueue timeout job, realm, milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enqueue timeout job must conform to the requirements in 9.5, 9.6 initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called: let realm be create realm, let new context be a new execution context, set the function of new context to null, set the realm of new context to realm, set the script4module of new context to null, push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object, created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global, this value 0. Let global objd. Set default global bindings, realm 1. Create any host-defined global object properties on global obj 2. Return unused 0.7 agents. An agent comprise is a set of ECMA script execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60. Copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification-level execution objects held within the agent. the running execution context, the execution context stack, and the agent record S fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithms get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block, a boolean, determines whether the agent can block or not. Signifier, an agent signifier, uniquely identifies the agent within its agent cluster. Is lock-free 1, a boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2, a boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8, a boolean, true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMA script implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See read shared memory and write shared memory for details. ECMA International 2024-161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR. Agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. 4. Example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note to the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the 3 agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3. If different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign. ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wait collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then THE embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination. With the termination data containing enough information to identify the agent that was terminated, each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waiter list record. Prior to any evaluation of any ECMA script code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial action declaration, a sync-generated declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generated declaration, a sync function declaration, a sync generated declaration, and variable declaration bindings. var names, a list of strings. The string names bound by function declaration, generated declaration, a sync function declaration, a sync generated declaration, and variable declaration declarations in global code for the associated realm. ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method purpose. Get this binding. Return the value of this environment records this binding. Has a declaration. N determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generated declaration, a sync function declaration, or a sync generated declaration. Has lexical declaration. N determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration. Has restricted global property. N determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding. Can declare global var. N determines if a corresponding create global var binding call would succeed if called for the same argument. N can declare global function. N determines if a corresponding create global function binding call would succeed if called for the same argument. N create global var binding. N D used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N, V, D, create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument D is true, the binding may be deleted. logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 4, 1 has binding, n, the has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, return true. Let OBJREC be envrec. Return OBJREC has binding, n, 1, 4, 2 create mutable binding, n, d, the create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the NAM that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If d is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, throw a type error exception. Return DCLREC create mutable binding, n, d, 1, 4, 3 create a mutable binding, n, s, the create immutable binding concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the NAM that is uninitialized. A binding must not already exist in this environment record for NFS is true. The new binding is marked as a strict binding. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, throw a type error exception. Return DCLREC create a mutable binding, n, s, for initialize binding, n, b, the initialize binding concrete method of a global environment record envrec takes arguments n, a string, and b, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, then a return DCLREC initialize binding, n, b, assert. If the binding exists, it must be in the object environment record. Let OBJREC be envrec. Return OBJREC initialize binding, n, b, 1, 4, 5 set mutable binding, n, v, s. The set mutable binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, then a return DCLREC set mutable binding, n, v, s. Let OBJREC be envrec. Return OBJREC set mutable binding, n, v, s, 1, 4, 6 get binding value, n, s. The get binding value concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is only if the binding is an uninitialized binding. Throw a reference error exception. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding n is true, then a return dclrec get binding value n s. ECMA International 2024 145. 3. Let objrec be envrec. Return objrec get binding value n s, 1 1 4 7. Delete binding n. The delete binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding n is true, then a return dclrec delete binding n. Let objrec be envrec. Let global object be objrec. Let existing prop be has own property global object n. If existing prop is true, then a. Let status be objrec delete binding n. B. If status is true and envrec contains n, then I remove n from envrec. C. Return status. Return true, 1 1 4. 8 has this binding. The has this binding concrete method of a global environment record envrec takes no arguments and returns true. It performs the following steps when called. Return true, 1 1 4. 9 has super binding. The has super binding concrete method of a global environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 4 1 0 with base object. The with base object concrete method of a global environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined 9 1 1 4 1 1. Get this binding. The get this binding concrete method of a global environment record envrec takes no arguments and returns a normal completion containing an object. It performs the following steps when called. Return envrec 146. ECMA International 2024. Note: global environment records always provide this binding. Note: global environment records do not provide a super binding. 9 1 1 4 1 2 has var declaration n. The has var declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called. Let var declared names be envrec. If var declared names contains n, return true, return false, 1 1 4 1 3 has lexical declaration n. The has lexical declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called. Let dclrec be envrec. Return dclrec has binding n, 1 1 4 1 4 has restricted global property n. The has restricted global property concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object n. If existing prop is undefined, return false. If existing prop is true, return false. Return true, the 1st of April 2015 can declare global var n. The can declare global var concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument, and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called: let objrec be envrec, let global object be objrec, let has property b, has own property, global object, n if has property is true, return true, return is extensible, global object. Note: properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147, 9, 1, 1, 4, 1, 6 can declare global function n, that can declare global function concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called: let objrec be envrec, let global object be objrec, let existing prop be global object, n if existing prop is undefined, return is extensible, global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values, true, enumerable, true, return false, 1, 1, 4, 1, 7 create global var binding, n, d, the create global var binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called: let objrec be envrec, let global object be objrec, let has property b, has own property, global object, n, let extensible b, is extensible, global object. If has property is false and extensible is true, then a perform. Objrec create mutable binding, n, d, b perform. Objrec initialize binding, n, undefined. If envrec does not contain n, then a append enter envrec 7. Return unused, 1, 1, 4, 1, 8 create global function binding, n, v, d, the create global function binding can cret e method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8 replaced. It performs the following steps when called: let objrec be envrec, let global object be objrec, let existing prop be global object, n if existing prop is undefined or existing prop is true, then a let desc be the property descriptor, v, true, true, d, else, a let desc be the property descriptor, v, perform. Define property or throw, global object, n, desc, perform. Set, global object, n, v, false. If envrec does not contain n, then a append enter envrec. Return unused, 48. ECMA International 2024. Note: global function declarations are always represented as own property.
Okay, so this
If
runs as it is.
property is reconfigured to have a standard set of attribute values,
I had to like
it's equivalent to what calling the initial
rename stuff, organize, I don't know, plan ahead.
same sequence of proxy trap calls, 1, 1, 5 module and
So like carefully renamed.
environment record is a declaration
Still builds.
is used to represent the outer scope of an ECMA script module. In additional to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another
The API, whatever, Vulkan API.
and records support all of the
It's like a soup of poop.
in table 16 and share the same specifications.
Everything's like
Get binding value, delete
just not organized.
binding. In addition,
So I have
records support the methods listed in table 22. Table
a template called qua to stand for,
and records the behavior of
I don't know, something.
methods for module environment records are defined by the following algorithms, comma,
Like object related
and get binding value.
to separate it from.
The get binding
I renamed everything that's Galloc to XMEM.
rect takes arguments n, a string, and s, a boolean,
I called the main Rumpelstiltskin.
containing an ECMA script language, a value or a
Oh, this is so boring.
It returns the value of its bound identifier whose name is n. However, if the binding is an indirect
So I carefully renamed
binding is
whatever I had here to V1 UX object.
as the reference,
So this is the type.
it performs the following steps when called assert.
Called it V1 because there might be a V2, a V3, a V4.
For n, if the binding for n is an
So this way I can like track down easily
direction values provided
V2, V3, V4.
created, v,
I think it's gonna take a couple revisions until I get it right.
v is empty,
Because this is a soup of poop.
v get binding
There's like a pipeline layout,
true. If the
and that's held by the pipeline. That makes no sense.
throw a reference error exception, return the value
A pipeline layout would like contain pipelines,
always be true because a module is always strict mode code 9, 1,
and the pipeline layout describes the property offsets.
delete bind
It's like
environment record is never used within this
it makes no sense. So I have to come up with a way
n, m,
to organize all this stuff.
direct binding in a module environment.
So like
The string value n is the text of the bound name. M is a module record.
if there is something common,
Module in
like if I have two quads,
turn the value of this in
one's green, if I'll make like a pink one or a blue one or red one, whatever.
National 2020
If I want to have them spin at different rates,
environment records
then I gotta push a different number. The context or the constant stack, whatever the fuck it's called.
resolve to a module in
You push constants, but they're really not constant.
3,
But you push them to the shader.
1,
So I want to push constants to the shader, but I gotta push that to different shaders.
environment record en
Well, the same shader,
and returns
but for different instances.
following steps when called return
Oh, this is so stupid.
5, forget this by
So that has to be shared.
concrete method of a module environment record env rec takes no arguments and returns.
It's like a hierarchy of things,
It performs the
and I gotta figure out
comma 1,
which things to put in the hierarchy,
create import
and which parts of this to split up.
m, and 2, the create import binding concrete method of a
Because anything that's common,
arguments n, a string,
I should just waste a little bit of memory holding a pointer
and returns unused. It creates a new initialized
to the common thing, even if it's not shared, rather than make a separate thing for every single thing.
2 is the name of a binding that exists in m's module environment
But I gotta figure out what to group and when and how to like
bound value of the type. It performs
split these things up.
when called assert. envrec does not already have a binding for
Because I'm doing this for this, and then I gotta do it for the tutorial
2, create
code, and it's using vertexes or vertices, whatever,
then 2 as its type
instead of using the shader itself.
is initialized, return on
It's passing them in,
to environment
so it's like slightly different.
following abstract operations are used in this specification to operate a
So I just like I gotta keep it working.
2
I can't break it. This way,
env
if it breaks, it breaks. I can undo,
the abstract operation
or at least have something that always works.
an
It's like a backup or whatever.
a string and strict
Because the shader, or not the shader,
either a nor
the tutorial does this stuff with the shaders or whatever.
action.
So I need this to get the shader program done.
If env is null, resolve
And right now all I have is this.
value.
This doesn't have an image on it.
BENV has binding.
But I want to clone this one, make a duplicate, make it spin like slower, faster,
The name
to make sure I have like this thing isolated. Then
2000
I also want to paint them to the same freaking frame
chords always provided this binding.
to make sure it's like
Return
I have it set up for two things to go to one frame or whatever. I don't know where the fuck to even do that.
2 to
The pipeline's common. The command buffer
new declarative
is different. Can you combine command buffers?
chord or null.
This stuff makes no sense.
Declarative environment record. It performs the following steps when called. Let env be in
The names, the naming convention for the stuff, for the terminology is ridiculous.
V, 1, 2, 3 new object environment O W E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O.
So like this one doesn't have an index buffer
V,
or a vertex buffer.
function environment F. New target
So this should probably be a separate struct
environment take
that's like pointed to.
ECMA script function object and new target
So if it's common between other things, then I can point to it when passing it in. But then the GPU also does that, kind of,
env be a new function environment record containing no bindings.
because some things can hold reference to the same thing.
To lexical
Oh my god, this is so frustrating.
env to new target. Set env to F. Return env, 1, 2, 5 new global environment.
But ended up with qua,
The abstract operation new global environment
v1 ubx, object, or whatever, that's the type.
an object and returns a global environment record. It performs
So it's template, then type, then whatever the type value is, variable.
false.
So we got global,
New declarative environment no
GC quad array, var. So I could put quad A, quad B, whatever.
env to this value. Set env to DCL rec. Set env to a new empty
Then this way,
L. Return env, 1, 2, 6.
everything the same types, grouped together.
The abstract operation
So if it's like a video game,
takes argument
I'd have enemy 1, enemy 2, if the same kind of enemy,
environment record.
stored in this array.
Following steps when called. Let env be a new module environment.
And if it's like a monster or something, if it's green monster, blue monster,
V. ECMA International 2024 151 9.2 private environment record.
that would go to here.
Record is a specification mechanism.
Where that be stored? I'm not sure. I gotta figure that out.
Typical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct.
I want to reuse all this code if possible.
Environment record is associated with a class
So if I have to make like a full-blown game engine,
time such a class
I'll have some kind of base to work with.
private environment record is created to
And I'm just trying to do like simple stuff, like a fucking flat plane.
environment record has the fields defined in table 20.
Maybe I should try doing more complicated stuff.
Private environment
It might be easier to find tutorials.
value type meaning outer private environment
I'm gonna Google what other people do really quick.
environment record
Probably not gonna find anything.
if the class with which this private environment record is associated is not
I'm gonna save back up and then
names, a list of private names, the private names declared by this class.
start grouping this stuff into this type and stuff, whatever.
Record operation
Isolate this type, make two of them,
are used in this
then get the image on the quad and gotta render them to the same frame.
to
The same frame. Or I gotta render them to the same frame first. Then I'll get this part done or whatever.
operation new private environment takes argument outer privy env, a private environment
Oh, this sucks.
returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy env, names, 2, 1, to resolve private identifier. Privy env, identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called let names be privy and v. For each private name Pn of names, do A if Pn is identifier. Then, I return Pn, let outer privy and v be privy and v. Assert. Outer privy and v is not null. Return resolve private identifier. Outer privy and v. Identifier. Point 3 realms. Before it is evaluated, all ECMA script code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24:52, copyright sign, ECMA International 2024, Table 24. Realm record fields, field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and v, an array, f. The agent that owns this realm, the global object for this realm, the G global environment for this realm, meaning the intrinsic values used by code associated with this realm. A list of records with fields are a string and a module record. Note 1: once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2: as mentioned in host load imported module 16.2.1.8. Note 1: in realm records is only used when running an import expression in a context where there is no active script for module. Field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9.3.1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called let realm rec be a new realm record. Perform create intrinsics. Realm rec, set realm rec to agent signifier, set realm rec to undefined, set realm rec to undefined, set realm rec to a new empty list, return realm rec, ECMA International 2024 153, 9.3. 2. Create intrinsics. Realm rec, the abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called set realm rec to a new record. Set fields of realm rec with the values listed in Table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function steps. Length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform add restrict. Add function properties. Realm rec, return unused, 3.3 set realm global object, realm rec, global obj, this value. The abstract operation set realm global object takes arguments realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called if global obj is undefined. Then, A. Let intrinsics be realm rec. B. Set global obj to ordinary object create intrinsics. Assert Global OBJ is an object. If this value is undefined, set this value to global OBJ, set realm rect to global OBJ, let new global env be new global environment, global OBJ, this value, set realm rect to new global env, return unused, 3.4 set default global bindings, realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called let global be realm rec. For each property of the global object specified in clause 19, do a let name be the string value of the property name, b let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. C perform. Define property or throw, global, name, desc, return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component, purpose, code evaluation state, any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMA script resources, script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in, first-out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component, purpose, lexical environment, identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment, identifies the environment record that holds bindings created by variable statements within this execution context. Private environment, identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27, ECMA International 2024 155. Table 27, additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code, let strict be true, else let strict be false. Return, get identifier reference, env, name, strict, 4.3 Get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment too. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding. 4.4 Resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion contained on an ECMA script language value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called. Let env-rec be get this environment. Return env-rec get this binding. 4.5 Get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let env-rec be get this environment. Assert env-rec has a field. Return env-rec, 4.6 Get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 Let current realm be the current realm record. Return current realm, jobs and host operations to enquire jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enquire generic job. capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enquid promise job and host enquid timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024-157. Note 1: host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority at any particular time. Script or module. A script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module. Is script or module. If script or module is a script record or module record. Let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMA script code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enquid by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields, 5.2 host make job callback. Callback. The host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note 2: host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG-HTML specification, https://html.spec.whatwg.org. For example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, V, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert. Is callable. Job callback. Is true. Return. Call. Job callback. Callback. V. Arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job. Job. Realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5, 5 host enqueue promise job. Job. Realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script or module beget active script or module at the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024-159. Note the realm for jobs returned by new promise resolve thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMA script code will be evaluated and no new ECMA script objects, for example error objects, will be created. The WHATWG-HTML specification, https://
The stream's almost at 12 hours.
.whatwg.org, for example, uses
I think I'm mostly gonna just piece this stuff together. Figure it out bit by bit.
html.spec.whatwg.org entry.
And I guess check, possibly, this documentation.
Job. Realm.
This documentation sucks. This API sucks.
Host enqueue timeout job text.
So I don't know, just figure it out.
A job abstract closure. Realm. A realm record. And milliseconds.
Because it sucks. That's the way it is.
Used. It schedules timeout job in the realm in the
Something like regroup, these objects that they're called. Tutorial. It says that, not tutorial.
Form to the requirements in 9.
The
Initialize host defined realm. The
documentation says that.
host defined realm.
It calls things that are not really objects, objects.
Store a throw completion. It performs
The terminology in this documentation,
let new context
the worst terminology ever.
the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the
Just want to figure out how to put all the pieces together
is now the running execution context. It
and make it whole.
an exotic object to serve as
Lots of fun. I just want to be done.
object.
So I'm about the stream go on for like 4 or 5 minutes
Otherwise,
because that's how I send the whole stream.
indicating that in order
Maybe we'll send the whole stream. I'll end the stream. I'll probably miss 30 seconds or so.
finding in realms
But if I like go on for like 5 minutes, you'll only miss like 30 seconds of that. So you won't miss the end of the stream, only a couple seconds.
wise, let this value be.
Because it's 2025
Global the
in modern streaming software.
object. Perform set realm
I don't know, you'd think that by 2025,
pro. Let
technology, software,
set default global bind
it wouldn't seem to be like the 1960s.
properties on global
There's more bells and whistles, but like at a fundamental level,
an agent
it's the 1960s.
script execution context.
So I'll start another stream in a bit. BRB.
Execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60. Copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent record S fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithms get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block, a boolean, determines whether the agent can block or not. Signifier, an agent signifier, uniquely identifies the agent within its agent cluster. Is lock-free 1, a boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2, a boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8, a boolean, true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMA script implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See read shared memory and write shared memory for details. ECMA International 2024-161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a Boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR. Agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. 4. Example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note to the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3. If different agents within an agent cluster have different values